Every single achievement in human history, the Great Wall of China, the pyramids of Egypt, the Manhattan Project, the Internet, landing on the moon, splitting the atom, combined together represents less than 1/10,000,000th of our species' true potential. That statement isn't hyperbole, it isn't motivational speaking. It's cold, mathematical fact based on a scale that measures civilizations not by their art, their philosophy, or their conquests, but by something far more fundamental, their ability to harness energy. In 1964, a Soviet astrophysicist named Nikolai Kardashev published a paper that would forever change how we think about intelligence in the universe. He wasn't trying to inspire anyone, he wasn't writing science fiction, he was solving a practical problem. How do you search for alien civilizations when you don't know what to look for? His answer created what we now call the Kardashev scale, and it reveals something that will fundamentally alter how you see your place in the cosmos. We are not an advanced civilization. We're not even close. On Kardashev's scale, we rate approximately 0.7. We haven't even reached level 1. A Type 1 civilization harnesses all the energy available on their planet. A Type 2 civilization captures the total power output of their star. A Type 3 civilization commands the energy of an entire galaxy containing hundreds of billions of stars. But here's what will keep you awake tonight. If such civilizations are possible, if the laws of physics permit beings to build structures that dwarf solar systems and harness the power of whole galaxies, then where are they? Why is the universe so eerily silent? The math is inescapable. The Milky Way galaxy is over 13 billion years old. If civilizations can advance through Kardashev levels, then millions of them should have reached Type 3 status by now. They should be impossible to miss. Their energy signatures should illuminate the cosmos like beacons. Yet when we scan the heavens with our most powerful telescopes, we find nothing. No Dyson spheres, no stellar engineering projects, no evidence of galactic-scale construction. The universe appears empty of advanced intelligence except for us. This absence has profound implications that extend far beyond academic curiosity. It suggests one of several terrifying possibilities. Either advanced civilizations are impossible, or they destroy themselves before reaching cosmic significance, or they're hiding from us for reasons we can't comprehend. The Kardashev scale forces us to confront the most important question our species has ever faced. Are we alone in our cosmic mediocrity, or are we on the verge of joining a community of advanced civilizations that spans the galaxy? Your life, your choices, your generation's decisions about energy, technology, and global cooperation aren't just determining the future of humanity. They're determining whether intelligence itself survives and thrives in this corner of the universe. The next hour will take you on a journey from our current cosmic insignificance to the possibility of commanding power that approaches the realm of gods. You'll discover why we might be living through the most important century in the history of consciousness itself. You'll learn why some scientists believe we could reach Type 1 status within the next few hundred years, while others warn we might destroy ourselves in the attempt. You'll explore what it would mean to cage the power of stars and why the silence of the cosmos might be the most important mystery facing our species. Most importantly, you'll understand why the Kardashev scale isn't just about energy consumption or technological advancement. It's about wisdom, responsibility, and the choices that determine whether consciousness becomes a cosmic force or remains forever trapped on isolated worlds. The scale that began as a tool for finding aliens has become a mirror that reveals humanity's destiny among the stars. What it shows us will change everything you thought you knew about our place in the universe. Chapter 1. The question that changes everything. You wake up tomorrow morning and everything looks exactly the same. Your house, your street, your city. But then someone whispers a secret in your ear that changes everything. They tell you that every single thing humanity has ever built, the Great Wall of China, the pyramids, every skyscraper, every bridge, every monument that has ever made you feel proud of what our species can achieve, all of it combined, represents less than 1/10 of 1% of what we're actually capable of. Your first reaction might be disbelief. How could that possibly be true? We've split the atom, sent humans to the moon, built computers that fit in our pockets and connect us to the entire world's knowledge in seconds. We've created art that moves us to tears, music that transcends language, and stories that unite us across cultures and centuries. Surely we've achieved something close to our full potential, right? But what if I told you that compared to what's theoretically possible for a civilization like ours, everything we've accomplished so far is like a single grain of sand compared to all the beaches on Earth? What if our greatest achievements are just the first tentative steps of a cosmic journey that could last millions of years and transform us into something almost godlike in our capabilities? This isn't science fiction, this isn't fantasy. This is the logical conclusion of a scientific framework that has fundamentally changed how we think about intelligence, progress, and our place in the universe. And understanding this framework might just be the key to ensuring our species doesn't just survive the next century, but thrives for millennia to come. The question I'm asking you to consider is simple, but its implications are staggering. What if we're not the advanced civilization we think we are? What if we're actually just cosmic toddlers, taking our first wobbly steps in a universe full of unimaginable possibilities? In 1964, while the world was focused on the Cold War, the space race, and the Cultural Revolution of the 1960s, a Soviet astrophysicist named Nikolai Kardashev was quietly working on a problem that would reshape our understanding of what it means to be an advanced civilization. He wasn't trying to build better rockets or create more powerful weapons. He was asking a question that no one had ever seriously considered before. How do you measure the advancement of an entire civilization? Think about that for a moment. We have ways to measure individual intelligence, national economic power, military strength, technological sophistication. But how do you measure the progress of an entire species? How do you compare humanity today to humanity 1,000 years ago or 1,000 years from now? What's the universal yardstick for cosmic advancement? Kardashev realized that almost everything we consider advanced, our technology, our culture, our achievements, depends on one fundamental thing: energy. Every computer calculation, every flight across the ocean, every light bulb, every heartbeat, every thought in your brain right now requires energy. Energy is the universal currency of capability. It's what allows complexity to emerge from simplicity, what permits intelligence to manipulate its environment, what makes growth and progress possible. But here's where Kardashev's insight becomes truly revolutionary. He realized that you could classify entire civilizations based on how much energy they could access and control. Not just how much energy they used, but how much energy was available to them from their cosmic environment. This wasn't just about being more efficient with fossil fuels or building better solar panels. This was about fundamentally different scales of energy access that would create fundamentally different types of civilizations. Imagine for a moment that you could travel through time and space, visiting civilizations throughout the universe. You might find a planet where the inhabitants have learned to harness every ray of sunlight that falls on their world, every geothermal vent, every wind current, every tidal force. You might discover another civilization that has built structures around their entire star, capturing virtually all of its energy output. And perhaps in the deepest reaches of space, you would encounter beings who have learned to harness the power of entire galaxies, commanding the energy of hundreds of billions of stars. These aren't just different degrees of the same thing. These are qualitatively different types of existence, as different from each other as a single-celled organism is from a human being. And Kardashev realized that this energy-based classification system could help us understand not just where we are, but where we might be going. Now you might be wondering, why should I care about this? I have bills to pay, relationships to maintain, dreams to pursue. What does some cosmic classification system have to do with my daily life? Here's the thing. The Kardashev scale isn't just an abstract way to categorize hypothetical alien civilizations. It's a mirror that reflects our own potential and our own choices. Understanding where we are on this scale helps us understand the challenges we face, the opportunities before us, and the decisions we need to make, both as individuals and as a species. Consider this: every major challenge facing humanity today, climate change, energy security, poverty, resource scarcity, is fundamentally an energy problem. We burn fossil fuels because we need energy, and that contributes to climate change. We fight wars over oil because energy means power. Billions of people live in poverty partly because they lack access to sufficient energy to improve their lives. Even our food system, our transportation networks, our manufacturing capabilities all depend on energy availability. The Kardashev scale suggests that these aren't just problems to be managed, but symptoms of our current evolutionary stage. We're stuck in what we might call an energy bottleneck. We have enough energy to create complex global civilization, but not enough to transcend the limitations and conflicts that energy scarcity creates. But here's where it gets personal. Your choices matter in this cosmic context. Every decision you make about energy use, every vote you cast, every career choice, every dollar you spend contributes to humanity's position on this scale. You're not just living your individual life, you're participating in the greatest adventure. In the history of our species, the journey toward becoming a truly advanced civilization. Think about your ancestors from 1,000 years ago. They lived in a world where most people never traveled more than a few miles from where they were born, where information moved at the speed of a horse, where disease and famine were constant threats. From their perspective, your life today would seem almost magical. You can communicate instantly with people on the other side of the planet. You can access more information in a few seconds than they could gather in a lifetime. You can travel distances in hours that would have taken them months. But the Kardashev scale suggests that your descendants, 1,000 years from now, might look back at us the same way we look back at medieval peasants. They might live in a world where energy is essentially unlimited, where the resources of entire solar systems are available for human use, where the barriers between worlds have been overcome. And your choices today help determine whether that future comes to pass. Let me introduce you to the 3 types of civilizations that define the Kardashev scale, but I want you to think about them not as abstract categories, but as 3 different stages of a cosmic journey that begins right here, with us, today. A Type 1 civilization has achieved something that might seem impossible from our current perspective. They have learned to harness and control all of the energy available on their home planet. Picture Earth, but imagine that we could capture every ray of sunlight that hits our atmosphere, every bit of geothermal heat from our planet's core, every gust of wind, every flowing river, every ocean current. Imagine that we could do this without destroying our environment, but instead by working in perfect harmony with natural systems. This isn't just about building more power plants. A Type 1 civilization represents a fundamental transformation in how a species relates to its home world. They would have achieved something unprecedented in Earth's history, a technological civilization that enhances rather than degrades its planetary environment. They would have solved the puzzle of unlimited clean energy, eliminated resource-based conflicts, and created a truly sustainable relationship with their planet. But let's expand our perspective beyond a single world. A A Type 2 civilization has achieved something even more extraordinary. They have learned to harness and control the total energy output of their star. Picture our sun, which every second converts 4 million tons of matter into pure energy, radiating more power than humanity has used in our entire history, every single second for the past 4.5 billion years. A Type 2 civilization would have built structures around their star to capture virtually all of this energy. They might construct vast arrays of solar collectors or rings of space habitats or even complete shells around their star. With this much energy at their disposal, they could support trillions of beings, terraform planets, travel between star systems, and undertake engineering projects on scales that defy our current imagination. But even this pales in comparison to the ultimate achievement of cosmic civilization. A Type 3 civilization has transcended the limitations of a single star system and learned to harness the energy of an entire galaxy. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. Each of those stars is a potential source of energy that could power a Type 2 civilization. A Type 3 civilization would have access to all of it. Think about what this means. A Type 3 civilization would have energy resources millions of times greater than a Type 2 civilization, which itself has energy resources millions of times greater than a Type 1 civilization. We're talking about differences in capability that are almost impossible to comprehend. A Type 3 civilization would be to us what we are to bacteria. They would be capable of engineering on galactic scales, potentially even manipulating the fundamental forces of physics, creating or destroying solar systems, guiding the evolution of entire regions of space. These aren't just bigger versions of what we have now. Each type represents a qualitative transformation, a fundamental change in what it means to exist as an intelligent species in the universe. Now here's where this story takes a turn that might surprise you and perhaps even unsettle you a little bit. When Kardashev first proposed his scale in 1964, he assumed that humanity was already a Type 1 civilization. After all, we had nuclear weapons, we were sending people to space, we had radio telescopes searching for signals from other civilizations. Surely we had mastered our planet's energy resources, right? But when modern scientists actually calculated humanity's current energy consumption and compared it to the total energy available on Earth, they made a shocking discovery. We're not Type 1. We're not even close to Type 1. In fact, we're barely scratching the surface of what's possible. Using the mathematical framework of the Kardashev scale, humanity today ranks at about 0.7. We're not even a full Type 1 civilization yet. We're still in the early stages of learning to harness our planet's energy resources. All of our achievements, everything we're proud of, everything that makes us feel advanced and sophisticated, represents less than 3/4 of the way to the first level of cosmic civilization. But here's what's even more startling. The transition from our current level to Type 1 might be the most dangerous period in our species' history. The same technologies that could propel us to Type 1 status, advanced nuclear power, space-based solar arrays, global energy networks, also carry risks that could destroy our civilization entirely. The path to becoming a cosmic civilization might require us to successfully navigate challenges that have already destroyed countless other species throughout the universe. And this raises a question that will haunt us throughout our journey together. If Type 1 civilizations are possible, if Type 2 and Type 3 civilizations are possible, if the universe should be filled with beings of unimaginable capability and wisdom, then where are they? Why does the cosmos seem so empty? Why haven't we detected any signs of these advanced civilizations? The answer to that question might determine whether humanity joins the ranks of cosmic civilizations or whether we become just another species that didn't quite make it to the stars. And understanding that answer starts with understanding exactly what it means to be trapped, as we currently are, on a single planet, struggling to harness even a fraction of the energy that surrounds us every day. The journey to the stars begins with a single step, but it's a step that could change everything. And that step begins with understanding exactly where we are right now and why the next few decades might be the most important in the history of our species. Are you ready to discover what it really means to be a civilization on the edge of cosmic transformation? Because the story we're about to tell will change how you see everything around you and everything that's possible for our future among the stars. Chapter 2. The Prisoners of Earth. Here's the truth that will fundamentally change how you see humanity's place in the universe. Right now, as you're watching this video, our entire species is trapped in an invisible cage, not by walls or bars, but by something far more subtle and far more limiting. We're prisoners of our own energy poverty. Every human achievement you've ever admired, from the Great Wall of China to the International Space Station, from the Internet to the most powerful supercomputers, all of it combined represents less energy than our sun produces in a single second, not a minute, not an hour. 1 second. And that's the uncomfortable reality that Nikolai Kardashev forced us to confront. We're not just behind where we could be, we're so far behind that we can barely see the starting line. Let me show you exactly what I mean. Imagine you're looking at a thermometer, but instead of measuring temperature, it measures civilization. At the bottom, you have cave dwellers who discovered fire. At the top, you have civilizations that command entire galaxies. Now, where do you think humanity sits on this scale? Most people guess we're somewhere in the middle. Some optimists think we're closer to the top. But here's the shocking reality. We're at 0.7, not 70%, not 7%, 0.7% of the way to becoming a true planetary civilization. Think about that for a moment. Everything we've built, every city that sparkles at night, every rocket we've launched, every quantum computer we've constructed, all of it adds up to less than 1% of what we need to achieve to truly master our own planet. And this isn't some arbitrary measurement. This is based on the fundamental currency of the universe itself, energy. Because here's what most people don't understand about civilization. It's not about culture. It's not about art. It's not about philosophy. At its core, civilization is about energy conversion. The more energy a species can harness and direct, the more it can achieve. The more it can create, the more it can become. This is why we're prisoners. Not because we lack imagination or ambition, but because we're running on the cosmic equivalent of pocket change while the universe offers us unlimited wealth. Now, why is energy the ultimate measure of civilization? Because energy is what transforms the impossible into the inevitable. Energy is what takes random atoms and organizes them into complexity. Energy is what takes dead matter and breathes life into it. Energy is what takes individual thoughts and weaves them into consciousness. Every great leap in human history has been fundamentally about energy. The agricultural revolution, that was about harnessing the energy stored in seeds and soil. The Industrial Revolution, that was about unlocking the energy trapped in fossil fuels. The Information Revolution, that's about using energy to manipulate electrons and photons to store and transmit information. But here's what's fascinating. Each of these revolutions didn't just give us more energy. They gave us more ways to use energy, more ways to organize it, more ways to direct it toward our goals. And each time, our definition of what was possible expanded dramatically. A single human being uses about 100 watts of energy just to stay alive. That's roughly equivalent to a bright light bulb. But when you add in everything that supports modern life, your home, your transportation, your food production, your communication systems, the average person in a developed country is responsible for using about 10,000 watts continuously. That's 100 times more energy than your body actually needs. And yet, even this seemingly enormous increase pales in comparison to what's possible. Because we're still thinking like inhabitants of a single planet, drawing energy from a tiny fraction of the resources available to us. Here's where the mathematics becomes breathtaking. Kardashev didn't just create 3 arbitrary categories, he created a precise mathematical framework based on orders of magnitude. And when you understand these numbers, you begin to grasp just how vast the universe's energy resources truly are. A Type I civilization uses approximately 10 to the power of 16 watts. That's 10 followed by 16 zeros. Written out, that's 10,000, watts. Humanity currently uses about 10 to the power of 13 watts. That means we need to increase our energy consumption by about 1,000 times to reach Type I status. Now that might sound impossible until you realize that we've already done this before. In 1800, global energy consumption was about 10 to the power of 10 watts. We've already increased our energy use by 1,000 times in just over 200 years, so the question isn't whether we can do it again. The question is how quickly we can do it and whether we can do it wisely. But here's where it gets truly mind-bending. A Type II civilization uses 10 to the power of 26 watts. That's 10 billion times more energy than a Type I civilization. And a Type III civilization, they use 10 to the power of 36 watts. That's 10 billion times more than Type II. To put this in perspective, imagine you're holding a grain of sand. That grain of sand represents humanity's current energy use. A Type I civilization would be like holding a small rock. A Type II civilization would be like holding a boulder the size of a house. And a Type III civilization, that would be like holding an entire mountain. So where does humanity's energy actually come from? And more importantly, where are we heading? Right now, we're living off the energy inheritance left to us by the sun. Fossil fuels are just concentrated sunlight that fell on Earth millions of years ago, captured by ancient plants and animals, and stored underground. We're basically burning the past to power the present. But here's the critical insight. We're only using a tiny fraction of the energy that's actually available to us. The sun delivers about 174 petawatts of energy to Earth every single day. Humanity uses about 18 terawatts. That means we're using about 1/10,000th of the solar energy that hits our planet. Imagine you inherited a mansion with 1,000 rooms, but you've only learned how to turn on the lights in one room. That's essentially our current energy situation. We're living in energy poverty in the middle of energy abundance. And this abundance isn't just theoretical, it's practical. We know how to build solar panels, we know how to build wind turbines, we know how to build hydroelectric dams, we know how to build geothermal plants. We're even learning how to build fusion reactors. The technology to dramatically increase our energy use already exists or is rapidly being developed. The question isn't whether we can become a Type I civilization. The question is whether we have the wisdom and coordination to get there without destroying ourselves in the process. So what would it actually look like to reach Type I status? What would need to change about how we live, how we organize our societies, and how we relate to our planet? First, we would need to completely transform our energy infrastructure. Instead of burning fossil fuels, we would need to directly harness the flows of energy that surround us. Solar energy from space, geothermal energy from deep within the Earth, fusion energy from recreating the processes that power the stars. But more than that, we would need to develop what scientists call a planetary energy grid. Instead of having separate energy systems for different countries and regions, we would need a truly global energy network that could capture energy wherever it's most abundant and distribute it wherever it's most needed. Imagine a world where the Sahara Desert's solar energy could power cities in northern Europe, where Iceland's geothermal energy could heat homes in Asia, where the wind energy of the world's oceans could be captured and distributed globally. That's the kind of energy integration that a Type 1 civilization would require. And here's what's remarkable. We're already beginning to see the early stages of this transformation. International power grids are being built, renewable energy costs are plummeting, energy storage technology is advancing rapidly, the foundation of a Type 1 energy system is already being laid. But reaching Type 1 isn't just about building bigger power plants, it's about fundamentally changing our relationship with energy itself. It's about seeing energy not as a resource to be consumed, but as a tool to be orchestrated. It's about understanding that the goal isn't to use more energy, but to use energy more intelligently. A Type I civilization wouldn't just have more energy, it would have more precise control over how that energy is used. It would be able to direct energy flows with the same precision that we currently direct information flows. It would be able to shape matter and organize systems on a planetary scale. But here's what Kardashev never fully anticipated. The path to Type 1 isn't just about overcoming technical challenges. It's about overcoming something far more difficult, the challenge of thinking like a planetary species instead of a collection of competing tribes. Because the technologies to reach Type 1 status, they're not just powerful, they're potentially dangerous. The same fusion technology that could provide unlimited clean energy could also be used to create weapons of unprecedented destruction. The same space-based solar arrays that could power our civilization could also be used as weapons from orbit. The same artificial intelligence systems that could manage a planetary energy grid could also be used to control and oppress. This is why some scientists believe we're approaching what they call the Great Filter, a test that determines whether a species has the wisdom to handle the power of cosmic civilization. And the question that keeps many researchers awake at night is this: what if most species fail this test? What if the reason we don't see Type 1 civilizations everywhere is because the transition from Type 0 to Type 1 is where most species destroy themselves? But before we dive into those darker possibilities, let me show you what success looks like. Let me show you what it means to be the masters of an entire world. Chapter 3. The Masters of Their World. Right now, at this very moment, humanity uses about 20 terawatts of power. That's 20 trillion watts flowing through our civilization.
Every second, it sounds enormous, doesn't it? But here's what will blow your mind. Our planet receives 174,000 terawatts of energy from the sun every single day.
We're using barely 1/10,000th of what's available to us. We're like someone dying of thirst while standing next to Niagara Falls. This is the reality of being a Type 0.7 civilization. We're not even masters of our own backyard. But what would it actually look like to become a Type 1 civilization? What would it mean to truly master our world? The answer isn't what most people think. When we imagine advanced civilizations, we often picture massive factories belching smoke, giant machines strip mining the planet, cities that sprawl endlessly across continents. But that's not mastery, that's desperation. That's the frantic scrambling of a species that doesn't understand the rules of the game it's playing. A true Type 1 civilization doesn't conquer its planet. It becomes one with it. Think of the most efficient system you know, your own body. Your heart doesn't fight your lungs. Your brain doesn't compete with your liver. Every organ works in perfect harmony, sharing resources, communicating constantly, supporting the whole. A Type 1 civilization treats its planet the same way. Not as a resource to be exploited, but as a living system to be harmonized with. But how do you harmonize with an entire planet? How do you capture the full energy budget
Of a world without destroying it in the process.
The first thing you need to understand about Type 1 technology is that it's not bigger versions of what we have now. It's not coal plants the size of cities or oil rigs that touch the clouds. Type I technology is fundamentally different because it works with natural systems instead of against them. Let's start with fusion power, because this is where the revolution truly begins. Right now, we're still burning things, coal, oil, gas, like cavemen around a campfire. But fusion? Fusion is the power of stars. Every second, our sun fuses 600 million tons of hydrogen into helium, releasing energy that will keep our planet warm for the next 5 billion years. A Type 1 civilization doesn't just dream about fusion, it makes fusion as common as electricity is for us today. Imagine fusion reactors not as massive, dangerous facilities locked away from civilization, but as clean, safe power sources integrated into every community. These aren't the unwieldy experimental reactors we're building today. Type I fusion technology would be as reliable as a modern smartphone, as safe as a home appliance, and as efficient as nature itself. But fusion is just the beginning. A Type I civilization also masters geothermal energy on a scale we can barely comprehend. Our planet's core burns at 6,000 degrees Celsius, hotter than the surface of the sun. Right now, we're barely scratching the surface of that power. But a Type I civilization would drill deeper, tap more efficiently, and extract heat from the Earth's core in ways that actually help stabilize our planet's geological systems. Then, there's solar power, but not solar panels scattered across rooftops. We're talking about solar collection systems that work in perfect harmony with Earth's ecosystems. Solar collectors that double as agricultural systems, feeding both our energy needs and our food needs simultaneously. Solar collectors in space, beaming clean energy down to Earth through precisely controlled microwave transmission. Solar collectors integrated into the very fabric of our cities, turning every surface into a power generator. Wind power becomes something entirely different in a Type 1 civilization. Instead of scattered windmills dotting the landscape, we're talking about integrated atmospheric management systems. These aren't just power generators, they're weather influencers, air purifiers, and climate stabilizers all rolled into one. They work with the natural flow of air currents, enhancing rather than disrupting the planet's atmospheric systems. But here's where it gets really interesting. The most advanced Type 1 energy systems aren't based on any single technology. They're based on integration. Every power source works together in a vast, interconnected network that spans the entire planet. Think of the most sophisticated network you interact with every day, the internet. Billions of devices, all connected, all sharing information instantly across the globe. Now imagine that same level of integration, but for energy instead of data. A Type I civilization builds what we might call a planetary nervous system for energy. Every power source, from the smallest rooftop solar panel to the largest fusion reactor, connects to every other power source. When it's sunny in Australia, that energy flows to power the evening rush hour in New York. When the wind is strong, over the Pacific, that power supports manufacturing in Asia. When geothermal systems in Iceland produce excess heat, that energy helps power agricultural systems in Africa. This isn't just about moving electricity around. This is about creating a living, breathing energy ecosystem that responds to need in real time. The system learns, adapts, and optimizes itself constantly. It knows when energy demand will spike before the spike happens. It redirects power around damaged areas automatically. It balances supply and demand across the entire planet without human intervention. But the real breakthrough isn't in the technology, it's in the efficiency. Current power grids waste enormous amounts of energy in transmission. Power plants have to run at full capacity even when demand is low because they can't quickly adjust their output. We build far more generating capacity than we actually need just to handle peak demand periods that last only a few hours each day. A planetary energy network eliminates all of that waste. Every kilowatt generated gets used productively. Peak demand gets spread across multiple time zones and seasons. Power sources complement each other instead of competing. The result is a system that can provide vastly more useful energy while actually using fewer raw resources than our current approach. And here's the beautiful part. This system grows stronger as it grows larger. Every new power source added to the network makes every other power source more efficient. Every new connection creates redundancy and resilience. A planetary energy network becomes more stable and more powerful with each expansion. But energy networks are just the foundation. What really defines a Type 1 civilization is how it uses that energy to transform its relationship with the planet itself. Here's where we need to completely flip our thinking about what it means to be an advanced civilization. We've been conditioned to think that more technology means more environmental damage, more industry means more pollution, more energy use means more resource depletion. But that's only true for inefficient civilizations, civilizations that don't understand the systems they're working within. A Type I civilization proves that the opposite is true. The more advanced your technology becomes, the more it enhances rather than degrades your environment. The more energy you use, the more efficiently you use it. The more you grow, the more sustainable you become. Think about how this works, right? Now, our industrial processes are crude and wasteful because we don't have enough energy to do them properly. We use environmentally harmful chemicals because the clean processes require too much power. We create pollution because we don't have enough energy to completely break down our waste products. We transport goods using fossil fuels because we don't have clean energy networks sophisticated enough to power electric transportation at scale. But with unlimited clean energy, all of those compromises disappear. Industrial processes can be designed for perfect efficiency rather than cost-cutting. Manufacturing can be completely clean because there's enough power to run every process at optimal conditions. Transportation becomes emission-free because clean energy is abundant everywhere. Waste becomes impossible because there's enough power to break down and recycle everything at the molecular level. A Type I civilization doesn't just avoid environmental damage, it actively heals environmental damage. With unlimited clean energy, you can extract carbon dioxide directly from the atmosphere and convert it into useful materials. You can desalinate ocean water without creating toxic brine. You can restore damaged ecosystems by providing the energy needed for accelerated plant growth and soil restoration. The atmosphere itself becomes manageable. Weather modification stops being science fiction and becomes routine engineering, not controlling the weather like some kind of cosmic dictator, but guiding it gently, helping natural systems work more efficiently. Hurricanes get weakened before they make landfall. Droughts get ended by precisely targeted rain enhancement. Heat waves get cooled by strategic cloud generation. Ocean acidification gets reversed through large-scale pH management systems. Ocean dead zones get restored through precise nutrient management and oxygenation. Coral reefs don't just survive, they thrive in carefully managed marine environments that provide optimal conditions for biodiversity. The key insight is that environmental harmony isn't about using less energy, it's about using energy more intelligently. A Type I civilization has so much clean energy available that it can afford to do everything the right way, the sustainable way, the harmonious way, but the most profound change isn't in our technology or our environment, it's in our society itself. When
energy becomes abundant, cheap, and clean, everything changes. Not just how we power our machines, but how we organize our entire civilization.
The social implications of Type 1 status are more revolutionary than the technological ones. Let's start with the most obvious change, the end of resource scarcity. Right now, so much of human conflict stems from competition for limited resources. Nations fight over oil reserves, communities struggle over water rights. Individuals compete for economic opportunities that depend on scarce energy resources. But in a Type 1 civilization, energy abundance eliminates most resource scarcity. When you have unlimited clean power, you can desalinate unlimited fresh water. You can synthesize materials from common elements. You can power vertical farms that produce food anywhere, regardless of climate or soil conditions. You can recycle everything completely, making raw materials effectively infinite. This doesn't mean everyone gets everything they want. Physics still imposes limits. But it means that basic needs become trivially easy to meet. Food, water, shelter, transportation, communication, education, all of these become so cheap to provide that they're essentially free. Not through government programs or wealth redistribution, but through pure technological abundance. When basic needs are met effortlessly, human society reorganizes around completely different principles. Instead of competing for survival resources, people compete for meaning, achievement, and creative expression. Instead of working jobs they hate to pay for necessities, people pursue work that fulfills them personally. Instead of economic systems based on scarcity management, we develop economic systems based on abundance optimization. The political implications are staggering. So many of our current political conflicts stem from disagreements about how to distribute scarce resources, tax policy, healthcare funding, education spending, infrastructure investment. All of these become non-issues when the underlying resources
are abundant. Political systems stop being about managing scarcity and start being about coordinating abundance. International relations transform completely. When every nation has access to unlimited clean energy, the geopolitical importance
of oil reserves disappears. When food and water can be produced anywhere, agricultural disputes become meaningless. When manufacturing can happen anywhere with equal efficiency, trade relationships become partnerships rather than dependencies. But perhaps the most profound change is in how humans think about their relationship with each other and with their planet. Scarcity thinking creates zero-sum mindsets, the belief that someone else's gain must be your loss. Abundance thinking creates positive-sum mindsets, the belief that everyone can win simultaneously. A Type I civilization naturally develops what we might call planetary consciousness. Not some mystical New Age concept, but a practical recognition that human welfare and planetary welfare are inseparable. When you have the technology to heal environmental damage, when you have the energy to do everything sustainably, when you have the abundance to meet everyone's needs, harming the planet or harming other people becomes obviously counterproductive. This shift in consciousness changes everything from individual behavior to international cooperation. People naturally make choices that benefit the whole system because they understand that they're part of the system. Nations naturally cooperate on global challenges because they understand that planetary health equals their own health. So could this actually happen? When might humanity achieve Type 1 status on the Kardashev scale? The answer depends on choices we're making right now, today, in this decade. The technology needed for Type 1 civilization isn't science fiction, it's engineering challenges we're already working on. Fusion power, advanced solar systems, global energy networks, environmental restoration technology, automated manufacturing, all of these exist in various stages of development. The optimistic timeline suggests we could reach Type 1 status within 100 to 200 years. That might sound like a long time, but it's remarkably fast for such a fundamental transformation of civilization. Consider that we went from the first powered flight to landing on the moon in just 66 years. We went from the first computer to the internet in less than 50 years. The technological acceleration we're experiencing now could compress the timeline to Type 1 status dramatically. The realistic timeline acknowledges that social and political changes take longer than technological ones. Even if we develop all the necessary technology in the next 50 years, integrating it into a global civilization will take additional time. Building planetary energy networks requires unprecedented international cooperation. Transforming economic systems requires careful management of social transitions. The realistic timeline suggests 200 to 500 years to full Type 1 status. The pessimistic timeline considers all the things that could go wrong. Climate change could disrupt technological development. Political conflicts could prevent international cooperation. Economic instability could reduce investment in necessary infrastructure. Resource depletion could force us to focus on survival rather than advancement. The pessimistic timeline suggests we might never reach Type 1 status, or might take 1,000 years or more. But here's what's fascinating about the timeline question. It's not predetermined. The speed at which humanity reaches Type 1 status depends entirely on the choices we make as a species. Every decision about energy policy, environmental protection, international cooperation, and technological investment moves us faster or slower along this timeline, and the most important choices aren't being made by governments or corporations. They're being made by individuals like you, right now, every day. Your career choices, your consumption patterns, your voting decisions, your personal values, all of these contribute to humanity's trajectory on the Kardashev scale. The question isn't whether we can become a Type 1 civilization. The technology is possible, the resources are available, and the benefits are clear. The question is whether we will choose to become a Type 1 civilization and how quickly we'll make that choice. But even as we struggle with the challenges of reaching Type 1 status, some scientists and engineers are already looking beyond to achievements so vast they challenge our understanding of what civilization can become. Because once you've mastered the power of a planet, the next logical step is to harness the power of a star. And that's when things get really interesting. The journey from Type 1 to Type 2 represents a leap not just in energy consumption, but in the fundamental scale of what we consider possible. It's the difference between being masters of our world and becoming builders of worlds. It's the difference between planetary engineering and stellar engineering. It's the difference between thinking like Earthlings and thinking like cosmic architects. But that's a story for another chapter. Right now, our focus needs to be on the immediate challenge in front of us, taking the first steps from our current Type 0.7 status toward true mastery of our planetary home. Because until we prove we can manage the power of a single world responsibly, we'll never be ready for the power of a star. Chapter 4. Caging the Sun. Right now, as you watch this video, our sun is pouring out more energy in a single second than humanity has consumed in our entire history. Every second, 4 million tons of solar mass converts to pure energy and radiates into space. Most of that incredible power simply vanishes into the cosmic void, unused, untapped, wasted. But what if it didn't have to be that way? What if there was a civilization advanced enough to capture not just a fraction of their star's energy, but all of it? Every photon, every burst of radiation, every ounce of stellar power flowing into technologies so advanced they seem like magic to us today. This is the realm of the Type 2 civilization on the Kardashev scale. And the engineering concept that makes it possible has a name that sounds like science fiction, but represents hard science fact. It's called a Dyson sphere, and it might be the most important idea you've never heard of. When Freeman Dyson first proposed his revolutionary concept in 1960, he wasn't trying to write science fiction. He was solving a very real problem that every advancing civilization must eventually face. As species grow more sophisticated, their energy needs don't just increase, they explode exponentially. Think about your own life for a moment. Your smartphone has more computing power than entire universities possessed 50 years ago. Your home uses more electricity in a month than most humans throughout history used in their entire lifetimes. Now multiply that progression by thousands of years of technological advancement. A Type 1 civilization, remember, harnesses all the energy of their planet. But here's the sobering reality check. Even if we captured every earthquake, every lightning bolt, every ray of sunshine that hits Earth, every tide, every gust of wind, the total energy budget of our entire planet represents less than 1/1000th of what our sun produces. Freeman Dyson understood this mathematical inevitability. Any civilization that continues to grow and develop will eventually bump up against the fundamental energy limits of their home world. And when that happens, they face a choice that will define their cosmic future. They can accept those limits and remain forever constrained to their planetary nursery, or they can think bigger, much bigger. The solution Dyson proposed was breathtaking in its audacity. Instead of trying to capture a fraction of stellar energy that happens to fall on their planet, why not build a structure around the entire star? Why not cage the sun itself? Now, when most people first hear about Dyson's spheres, they imagine something like the Death Star from Star Wars, a solid shell completely surrounding a star. But that's not what Dyson actually proposed, and here's why that matters for understanding just how incredible these structures really are. A solid sphere around our sun would need to be roughly 93 million miles in radius, the distance from Earth to the sun. The surface area of such a structure would be 500 million times larger than Earth's surface. The engineering challenges would be literally astronomical. The materials required would exceed the mass of several planets. And that's just the beginning of the problems. What Dyson actually envisioned was something far more elegant and achievable, what we now call a Dyson swarm. Instead of one massive structure, imagine millions or even billions of individual collectors, each one orbiting the star independently, each one designed to capture and convert stellar energy into usable power. These collectors wouldn't be crude solar panels like we use today. We're talking about sophisticated technologies that could harvest not just visible light, but the entire electromagnetic spectrum radiating from the star. X-rays, gamma rays, infrared radiation, radio waves, every form of energy the star produces would be captured and channeled into the civilization's power grid. But here's where the concept becomes truly mind-bending. A complete Dyson swarm wouldn't just provide enormous amounts of energy, it would provide living space on a scale that dwarfs anything we can imagine. Each collector could be the size of a continent, or even larger. Some could be designed as habitats, supporting billions of individuals in artificial worlds with perfect climate control and unlimited resources. The total living space available in a completed Dyson swarm would be trillions of times larger than Earth's surface. A single Type 2 civilization could support more conscious beings than have ever existed in the history of our planet, all living in comfort and abundance that makes our current lifestyle look primitive by comparison. Now, I know what you're thinking. This all sounds like fantasy, like something so far beyond our current capabilities that it might as well be magic. But let's break down exactly what would be required to build a Dyson swarm, because the engineering challenges, while enormous, aren't actually impossible. The first challenge is materials. Building millions of collectors requires unprecedented amounts of raw materials, but here's where the physics works in our favor. Our solar system contains more than enough material to build a complete Dyson swarm. The asteroid belt alone contains enough metal and rock to construct collectors with a combined mass thousands of times greater than Earth. Mercury, the innermost planet, is particularly interesting for Dyson construction. It's incredibly rich in metals, has no atmosphere to complicate mining operations, and receives 25 times more solar energy per square meter than Earth does. A Type 2 civilization could systematically disassemble Mercury, using its mass to build the very collectors that would make their civilization possible. But how do you actually build structures this large in space? The answer lies in self-replicating manufacturing systems, machines that can build copies of themselves using raw materials. Once you have a small number of these systems operating in space, they can exponentially multiply, creating the industrial capacity needed for megascale construction projects. The construction process would likely take centuries or even millennia, but remember, we're talking about civilizations that think in cosmic timescales. Each completed collector would provide more energy than entire regions of their home planet, funding the construction of additional collectors in an accelerating cycle of growth and expansion. The individual collectors themselves would need to be marvels of engineering. They'd require sophisticated orientation systems to track the star, advanced materials that can withstand intense radiation and thermal cycling, and communication networks that allow millions of independent structures to function as a coordinated system. But perhaps the most impressive aspect of Dyson swarm engineering is the power transmission system. How do you get the energy from millions of collectors to the places where it's needed? The answer likely involves beamed power transmission, using focused microwave or laser beams to send energy across space with minimal loss. Close your eyes for a moment and try to imagine what daily life might be like for someone living in a completed Dyson swarm. You wake up in a habitat that's larger than most countries, but engineered to feel like the most beautiful natural environment you can. Imagine. The climate is perfect, the air is pure, and the artificial sun that illuminates your world never sets unless you want it to. Your home isn't just a house, it's a customized environment that can transform itself based on your needs and desires. Want to spend the morning in a tropical paradise? The walls dissolve into lush jungle. Prefer a cozy mountain cabin for the afternoon? The habitat reconfigures itself accordingly. The boundary between artificial and natural becomes meaningless when you have unlimited energy and advanced nanotechnology. But the real transformation isn't in the physical environment, it's in the fundamental economics of existence. In a Type 2 civilization, scarcity becomes obsolete. Energy is essentially unlimited, raw materials are abundant, and automated systems handle all the basic necessities of life. This isn't just wealth as we understand it. This is post-scarcity economics where the very concept of want or need disappears. What do conscious beings do when all their physical needs are automatically met? They pursue growth, creativity, exploration, and connection on scales we can barely comprehend. They might spend centuries mastering artistic forms that don't exist yet, or dedicate lifetimes to scientific research that advances knowledge across their entire civilization. The social structures of Dyson civilizations would be unlike anything in human history. With virtually unlimited resources and living space, the competitive pressures that drive conflict in resource-limited societies simply disappear. Cooperation becomes the natural state because there's no need to compete for scarce resources. Communication across a Dyson swarm presents fascinating challenges and opportunities. Light takes several minutes to travel from one side of our solar system to the other, which means real-time conversation across the entire swarm would be impossible. Instead, Dyson civilizations might develop new forms of social organization based on local communities that stay in constant contact, connected to a broader network through delayed but rich information exchange. Here's where science fiction becomes cutting-edge science fact. Right now, at observatories around the world, astronomers are actively searching for signs of Dyson spheres around other stars. And the techniques they're using are so clever, so elegantly simple, that they might have already found evidence of Type 2 civilizations without realizing it. The basic principle is surprisingly straightforward. A star surrounded by a Dyson swarm would look different from a normal star when viewed through our telescopes. The collectors would absorb the star's visible light and re-emit it as infrared radiation. So astronomers look for stars that are dimmer than expected in visible light, but brighter than expected in infrared. They also look for unusual dimming patterns. When the collectors in a Dyson swarm pass between us and their star, they would create irregular, complex patterns of dimming that are completely different from the regular, predictable dimming caused by planets. The most famous candidate for a possible Dyson sphere is a star called KIC 8462852, nicknamed Tabby's star after astronomer Tabitha Boyajian, who first studied its unusual behavior. This star exhibits bizarre dimming patterns that don't match anything astronomers expected to see from natural phenomena. The dimming is irregular, dramatic, and unlike anything caused by planets or other known objects. Now, most astronomers think Tabby's star is probably caused by natural phenomena we don't fully understand yet, perhaps clouds of dust or swarms of comets. But the fact that we can't easily explain its behavior with conventional astronomy keeps the Dyson sphere hypothesis alive as a remote possibility. The search for Dyson spheres represents something profound about human nature. We're not content to simply wonder whether advanced civilizations exist. We're actively developing the tools and techniques to find them. Every unusual star, every unexplained signal, every anomaly in our data might be the first evidence that we're not alone in the universe. But there's also something sobering about this search. We've examined thousands of stars, developed increasingly sophisticated detection methods, and found very little that clearly indicates the presence of Type 2 civilizations. This absence of evidence doesn't prove they don't exist, but it does suggest that either such civilizations are incredibly rare or they're so advanced that their technology is indistinguishable from natural phenomena. Building a Dyson swarm around a single star is just the beginning for a Type 2 civilization. With virtually unlimited energy at their disposal, such a civilization would naturally begin to look outward toward other star systems, toward the broader galaxy. The energy budget of a complete Dyson swarm is so enormous that it could power interstellar missions on scales we can barely imagine. Instead of sending small robotic probes to nearby stars, a Type 2 civilization could launch entire artificial worlds, complete with populations in the millions or billions, toward promising star systems. These wouldn't be desperate colonial missions like something out of science fiction. They'd be carefully planned expansions, with each new star system receiving the full industrial and technological capability needed to construct its own Dyson swarm. The original civilization wouldn't lose anything by expanding. They'd be creating new nodes in an ever-growing network of stellar engineering projects. The timescales involved in interstellar expansion are vast by human standards, but manageable for civilizations that think in cosmic terms. Even traveling at a modest fraction of light speed, robotic systems could reach nearby stars within centuries, carrying the technology needed to begin construction of new Dyson swarms around those stars. But here's where the mathematics of expansion become truly staggering. Once a Type 2 civilization begins expanding to other star systems, the growth becomes exponential. Each new Dyson swarm provides the energy needed to launch multiple additional expansion missions. Within a few million years, a blink of an eye in cosmic terms, a single Type 2 civilization could theoretically construct Dyson swarms around every star in their local region of the galaxy. This exponential expansion capability is one of the reasons why the absence of detected Dyson spheres is so puzzling. If Type 2 civilizations are possible, and if they naturally expand to other star systems, then the galaxy should be full of their constructions. The fact that we don't see obvious signs of such civilizations raises profound questions about the nature of advanced intelligence in the universe. This brings us to one of the most unsettling implications of the Dyson sphere concept. If building stellar-scale megastructures is a natural step in the development of advanced civilizations, and if such civilizations would naturally expand to multiple star systems, then where are they? Our galaxy contains roughly 400 billion stars. Many of these stars are billions of years older than our Sun, which means they've had billions of years more time to develop advanced civilizations. If even a tiny fraction of these star systems developed Type 2 civilizations, the galaxy should be teeming with Dyson swarms. Yet when we look out into space, we see what appears to be a galaxy full of normal, unmodified stars. We don't see the infrared signatures of massive energy collection. We don't see the dimming patterns of megastructures. We don't see the regular geometric arrangements of artificial objects that would indicate stellar engineering projects. This apparent absence of Type 2 civilizations intensifies what scientists call the Fermi paradox, the contradiction between the high probability that advanced civilizations should exist and the complete lack of evidence for their existence. Dyson spheres make this paradox even more stark because they represent such obvious signatures of advanced technology. There are several possible explanations for this cosmic silence, and each one has profound implications for humanity's future. Maybe Type 2 civilizations are incredibly rare, suggesting that the progression up the Kardashev scale is far more difficult than we assume. Maybe they tend to destroy themselves before reaching Type 2 status, a possibility that should concern us as we develop increasingly powerful technologies. Or maybe they do exist, but they're so advanced that their technology appears natural to our current level of understanding. A sufficiently sophisticated Dyson swarm might harvest stellar energy so efficiently that it produces no detectable waste heat. Or perhaps Type 2 civilizations discover energy sources that make stellar engineering obsolete, leading them to abandon or never build Dyson-scale structures. There's also the possibility that advanced civilizations choose to remain hidden, either to avoid contact with younger species like ourselves, or because they've learned that advertising their presence in the galaxy is dangerous. This raises the intriguing question of whether we should be actively searching for signs of advanced civilizations, or whether we should be more concerned about remaining undetected ourselves. As we stand on the threshold of potentially becoming a Type 1 civilization, the concept of Type 2 status seems impossibly remote. The gap between harnessing our planet's energy and caging our star appears so vast that it might take tens of thousands of years to bridge, if it's possible at all. But remember that the progression up the Kardashev scale isn't just about building bigger power plants or more sophisticated technologies. It's about fundamentally changing how we think about our relationship with the cosmos, about what's possible, about our responsibilities as conscious beings in an apparently empty universe. A Type 2 civilization doesn't just capture the energy of their star, they become gardeners of stellar systems, architects of worlds, custodians of energies that dwarf anything in human experience. They don't just harness natural forces, they become natural forces themselves, shaping matter and energy on scales that blur the line between technology and cosmic phenomena. But even the incredible achievements of a Type 2 civilization pale in comparison to what might be possible for species that continue to advance up the Kardashev scale. Because beyond the power of single stars lies an even more mind-bending possibility. Civilizations that command not just one star, but hundreds of billions of them. What happens when you don't just cage a single sun, but harness the combined energy of an entire galaxy? Chapter 5. Lords of the Galaxy. Right now, as you sit watching this, light from our sun is traveling at 186,000 miles per second toward the edge of our solar system. But here's what will blow your mind. That same light would need over 4 years just to reach our nearest neighboring star and our galaxy. Our Milky Way contains between 200 and 400 billion stars, each potentially harboring worlds, civilizations, entire histories we'll never know. This is the scale we're dealing with when we talk about Type 3 civilizations. These aren't just advanced societies that have figured out how to harness their planet's energy or even their star's energy. These are civilizations that have achieved something so monumentally ambitious that it challenges every assumption you've ever had about what intelligence can accomplish in the universe. A Type 3 civilization has learned to harness the energy output of an entire galaxy. Not just one star, not just 1,000 stars, but hundreds of billions of stars simultaneously. The number is so staggering that if you tried to count every star in our galaxy at a rate of 1 per second, it would take you over 10,000 years working non-stop, never sleeping, never eating, just counting. But here's where it gets really interesting. Energy isn't just about powering spaceships or keeping the lights on. Energy is the fundamental currency of complexity itself. The more energy a civilization can harness and direct, the more sophisticated their technology becomes, the more intricate their society can be, and the more profound their understanding of the universe grows. When we talk about galactic-scale civilizations, we're not just talking about bigger versions of what we know. We're talking about forms of intelligence and organization that operate on timescales and spatial scales that stretch the very definition of what we consider life, consciousness, and civilization. So what exactly defines a Type 3 civilization? The numbers alone are mind-bending. We're talking about a civilization that can harness approximately 10 to the 37th watts of power. To put that in perspective, that's about 10 billion times more energy than a Type 2 civilization uses, which itself uses 10 billion times more energy than a Type 1 civilization. But the real achievement isn't just the energy consumption. It's what that energy enables. Think about this. Right now, with all of humanity's technology, all our satellites, all our communication networks, we can barely manage to coordinate activities across our single planet. We struggle with time zones, language barriers, and cultural differences across just 24,000 miles of circumference, a Type 3. Civilization has solved the coordination problem across a galaxy that's 100,000 light-years in diameter. They've figured out how to maintain coherent organization, shared purpose, and coordinated action across distances so vast that a message sent from one end of their civilization to the other would take 100,000 years to arrive, even traveling at the speed of
light. This isn't just an engineering achievement.
This is a complete reimagining of what consciousness, intelligence, and society can become. These civilizations have transcended the limitations that bind us to thinking in terms of human lifespans, planetary boundaries, and the speed of light as a communication barrier. But here's what's fascinating. They didn't get there by accident. Every Type 3 civilization represents the successful navigation of countless existential challenges that could have destroyed them. They've survived their equivalent of climate change, nuclear weapons, artificial intelligence risks, resource depletion, and probably dangers we haven't even imagined yet. They've not only survived these challenges, but thrived through them to become something we can barely comprehend. When you can harness the energy of an entire galaxy, what kinds of projects become possible? This is where our imagination starts to break down, because we're talking about engineering on scales that dwarf anything in human experience. Consider stellar engineering. A Type 3 civilization doesn't just build structures around stars, they redesign the stars themselves. They can extend stellar lifetimes by carefully controlling nuclear fusion rates. They can harvest material from dying stars to fuel the birth of new ones. They can even move entire star systems, relocating them to more advantageous positions within the galaxy. Think about what this means. These civilizations are essentially gardeners of the galaxy, but instead of tending flowers, they're cultivating entire solar systems. They can take a dying red giant star and transform it into a stable, long-lived star that will provide energy for billions of additional years. They can move planetary systems away from dangerous cosmic events like supernovas or black hole mergers. But the engineering doesn't stop with individual stars. Type 3 civilizations likely construct galactic-scale infrastructure. Imagine networks of artificial structures that span thousands of light-years, connecting star systems in ways that allow for rapid transportation and communication across the galaxy. We're talking about engineering projects that use entire asteroid belts as raw materials and harness the energy of quasars to power construction on unimaginable scales. These civilizations might build what we call Alderson disks, massive structures that completely surround stars, but unlike Dyson spheres, these disks could be millions of times larger than Earth's orbit. They could construct artificial worlds that dwarf anything we can imagine, with surface areas billions of times larger than Earth's, capable of supporting populations that number in the quadrillions. Some scientists speculate that Type 3 civilizations might even engage in galactic-scale terraforming, systematically transforming entire regions of the galaxy to be more hospitable to life. They could seed new worlds with life, guide the evolution of species, and create vast networks of inhabited systems that span thousands of light years. The tools available to such civilizations are equally mind-boggling. They likely have complete mastery over matter at the atomic level, able to transmute elements at will and construct materials with properties we can't even theorize. They probably harness exotic forms of energy we haven't discovered yet, possibly tapping into dark energy or finding ways to extract energy from the vacuum of space itself. But here's one of the most fascinating puzzles about Type 3 civilizations. How do they communicate and coordinate activities across galactic distances? This isn't just a technical problem. It's a fundamental challenge that strikes at the heart of what it means to be a unified civilization. Light, the fastest thing in the universe, takes 100,000 years to cross our galaxy. This means that a message sent from one edge of a Type 3 civilization to the other would arrive 100,000 years after it was sent. Imagine trying to have a conversation where every response takes 200,000 years. Imagine trying to coordinate a galactic project where news of success or failure in one region doesn't reach other regions for millennia. This forces us to completely reimagine what consciousness and identity mean on such scales. Perhaps Type 3 civilizations develop forms of collective consciousness that transcend individual minds. Maybe they create artificial intelligences so advanced that local nodes of the civilization can make decisions autonomously while still maintaining coherence with the galactic whole. Some theorists suggest these civilizations might discover ways to communicate faster than light, possibly through quantum entanglement or by manipulating space-time itself. Others propose that they might exist in higher dimensions where the normal rules of distance and time don't apply in the same way. But there's another possibility that's even more intriguing. Maybe Type 3 civilizations don't need rapid communication because they think and plan on timescales that make our entire recorded history seem like a brief moment. Maybe they're so long-lived and patient that waiting 100,000 years for a message is like waiting a few minutes for a text response. This raises profound questions about the nature of time and consciousness. If you lived for millions of years, would a century feel like a day does to us? If your civilization had been continuously developing for hundreds of millions of years, would the rise and fall of entire species seem like seasonal changes? Rather than thinking of Type 3 civilizations as conquerors or consumers, many scientists now believe they would function more like cosmic gardeners, carefully tending to the development of life and intelligence throughout their galaxy. This perspective radically changes how we think about advanced civilizations. Instead of strip mining planets and consuming resources until they're depleted, Type 3 civilizations likely understand that their long-term success depends on maintaining the health and diversity of the galactic ecosystem they inhabit. They might actively seed new worlds with life, carefully guiding the evolution of species to increase the overall complexity and beauty of the galaxy. They could protect younger civilizations from cosmic catastrophes, subtly steering asteroids away from inhabited worlds or shielding planets from dangerous radiation. This galactic gardening might explain why we haven't detected obvious signs of Type 3 civilizations. If they're truly advanced, they would understand that a galaxy filled with diverse, independent civilizations is far more valuable than a galaxy strip-mined for resources. They might deliberately maintain the appearance of naturalness, allowing younger species like ourselves to develop without feeling overshadowed or controlled. Some scientists speculate that Type 3 civilizations might maintain vast reserves of untouched space, preserving entire regions of the galaxy as cosmic wilderness areas where natural evolution can proceed without interference. They could act as shepherds of galactic diversity, ensuring that the universe continues to generate new forms of life, consciousness, and creativity. This perspective suggests that Type 3 civilizations have transcended the scarcity mindset that dominates our current thinking. When you can harness the energy of hundreds of billions of stars, when you can live for millions of years, when you can create matter from energy and design worlds to your specifications, your priorities shift from acquisition to cultivation, from consumption to creation. One of the most mind-bending aspects of Type 3 civilizations involves their relationship with time. These are civilizations that have existed for so long that our entire species' history represents just a tiny fraction of their experience. Consider this. Humans have existed as a species for roughly 300,000 years. Our recorded history spans about 5,000 years. The entirety of human civilization, from the first cities to space exploration, has unfolded in less than 10,000 years. To a Type 3 civilization that has existed for millions or billions of years, our entire history would be like a few weeks. In their experience, this temporal perspective fundamentally changes everything about how such civilizations would think and act. They've witnessed the birth and death of countless species, the formation and destruction of countless worlds, the rise and fall of countless civilizations. They've seen patterns repeat across cosmic timescales that give them a perspective on
existence that we can barely imagine. But this raises fascinating questions about identity and continuity.
what makes a civilization the same civilization across millions of years of existence. The individual members certainly don't live that long, so what preserves the continuity of culture, purpose, and identity? Perhaps Type 3 civilizations have achieved forms of consciousness that transcend individual biological existence. Maybe they've uploaded their minds into substrates that can last for geological time periods, or maybe they've developed forms of collective consciousness where individual identity becomes part of a larger, more permanent whole. Some theorists suggest that Type 3 civilizations might exist in a state of what we could call practical immortality, not because individuals live forever, but because the civilization has become so stable and robust that it can survive any conceivable catastrophe. They've diversified across so many star systems, backed up their knowledge and culture in so many ways, and developed such powerful technologies that the civilization itself becomes immortal, even if its individual components are not. This immortality isn't just about survival, it's about continuous growth and development. These civilizations haven't just learned to persist, they've learned to evolve and adapt across cosmic timescales. They've become learning organisms that grow wiser and more capable with each passing eon. So if Type 3 civilizations are possible, and if they would wield such incredible power, why haven't we detected them? This question has driven astronomers to develop increasingly sophisticated methods for searching for signs of galactic-scale engineering. The search focuses on what we call technosignatures, evidence of large-scale technological activity that would be visible across interstellar distances. If a civilization is harnessing the energy of an entire galaxy, that activity should leave detectable traces. Astronomers look for unusual patterns in galactic energy distribution. They search for galaxies that seem to emit less light than they should, possibly because their energy is being harvested by advanced civilizations. They look for unusual infrared signatures that might indicate massive engineering projects converting starlight into usable energy. Some researchers search for signs of stellar engineering, stars that behave in ways that suggest artificial manipulation. They look for star systems that have been moved from their natural positions, or stars whose energy output has been artificially modified. They search for evidence of massive structures that partially block starlight in patterns too regular to be natural. The search also involves looking for communication signals that might span galactic distances. These wouldn't be simple radio messages like we might send, but massive galaxy-spanning communication networks that would require enormous amounts of energy to operate and would be detectable across cosmic distances. But here's what's puzzling. Despite decades of searching with increasingly powerful instruments, we haven't found definitive evidence of Type 3 civilizations anywhere in the observable universe. This absence of evidence creates what scientists call the galactic habitable zone paradox. If Type 3 civilizations are possible and beneficial, why don't we see them everywhere? The most unsettling possibility is that Type 3 civilizations are extremely rare, not because they're impossible to achieve, but because most civilizations destroy themselves before reaching that level. Maybe the journey from Type 2 to Type 3 involves navigating existential risks so severe that very few civilizations successfully make the transition. Alternatively, maybe Type 3 civilizations are so advanced that their activities are completely invisible to us. They might use technologies we can't detect, operate in dimensions we can't perceive, or have transcended physical reality in ways that make them undetectable to civilizations like ours that are still bound by conventional physics. This brings us face to face with one of the most profound mysteries in all of science, the Fermi paradox. If the universe is old enough and large enough for Type 3 civilizations to have evolved, and if such civilizations would be detectable across cosmic distances, then where are they? The paradox becomes even more acute when we consider the Kardashev scale. Type 3. Civilizations should be cosmic lighthouses visible across billions of light years. Their engineering projects should be so massive that they fundamentally alter the appearance of their host galaxies. Their communication networks should be detectable by any civilization advanced enough to build radio telescopes. Yet when we look out into the universe, we see what appears to be a vast, empty cosmos operating according to natural laws with no signs of intelligence or purpose beyond what evolution has produced on Earth. The galaxies we observe appear to be following natural patterns of formation and evolution with no evidence of large-scale engineering or management. This cosmic silence suggests several possibilities, each more disturbing than the last. Maybe intelligence is so rare in the universe that we're alone, or nearly alone, in our galaxy. Maybe the step from Type 2 to Type 3 civilizations is so difficult that it's never been successfully achieved anywhere in the observable universe. Perhaps most unsettling is the possibility that Type 3 civilizations do exist, but they're so far beyond our current understanding that we can't recognize their signatures. Maybe what we interpret as natural cosmic phenomena are actually the artifacts of engineering projects so advanced that they're indistinguishable from natural processes. Or maybe, and this is the possibility that keeps many scientists awake at night, Maybe there's something called the Great Filter that prevents civilizations from reaching Type 3 status. Maybe there's some existential challenge that arises during the transition from Type 2 to Type 3 that destroys almost every civilization that attempts it. If that's the case, then understanding the Kardashev scale isn't just an academic exercise, it's a survival manual for humanity, because if we're going to join the ranks of cosmic civilizations, we need to understand not just what's possible, but what's dangerous about the journey ahead. The silence of the cosmos might not
Be an accident. It might be a warning. A warning.
Chapter 6. The Great Silence. Right now, at this very moment, you are part of something extraordinary. You are a member of the only known intelligent civilization in a galaxy containing over 400 billion stars. Think about that number for a second. 400 billion opportunities for life, for intelligence, for civilizations that could have mastered their planets, captured their stars, or commanded entire galactic regions. And yet, when we look up at the night sky, we see nothing but silence. This isn't just an interesting scientific curiosity. This is the most profound mystery our species has ever encountered, and it cuts to the very heart of what the Kardashev scale reveals about our universe. Because if civilizations can progress from Type 0 to Type 3, if they can grow from planetary prisoners to galactic gardeners, then our galaxy should be buzzing with activity. It should be impossible to miss the signatures of advanced civilizations. The fact that we see nothing, hear nothing, detect nothing should terrify us in ways we're only beginning to understand. Every time you've looked up at the stars and felt a sense of wonder, you've been staring directly at the greatest mystery. In science, the universe appears to be almost incomprehensibly vast, filled with countless worlds that could harbor life, and yet it seems to be utterly, completely, devastatingly empty of the kind of intelligence that could build Dyson spheres or engineer galaxies. This emptiness has a name, and understanding it might determine whether humanity has a future among the stars or whether we're destined to join the Great Silence ourselves. In 1950, during a casual lunch conversation at Los Alamos National Laboratory, physicist Enrico Fermi asked a question that still haunts scientists today. He simply asked, "Where is everybody?" Fermi had been discussing UFO reports with his colleagues, but his question went much deeper than flying saucers. He was pointing to a fundamental contradiction that should keep every thinking person awake at night. Here's the mathematical reality that Fermi understood. Our galaxy is approximately 13.6 billion years old. Earth formed about 4.5 billion years ago, and complex life took billions of years to evolve. But here's the crucial point that connects to everything we've learned about the Kardashev scale. If any civilization in our galaxy had achieved Type 2 status just 1 million years ago, which is virtually yesterday, in cosmic terms, they would have had enough time to spread throughout the entire galaxy multiple times over. Let me make this concrete for you. If a Type 2 civilization sent out just one generation ship every 1,000 years, traveling at just 10% the speed of light, they could colonize every star system in the galaxy in less than 10 million years. That's assuming they move slowly and cautiously. A truly advanced Type 2 civilization could accomplish this in a fraction of that time. Now consider this sobering fact. There are stars in our galaxy that formed 10 billion years ago, giving any civilizations around them a 6 billion year head start on us. In cosmic terms, they should have colonized the galaxy hundreds or even thousands of times over. By the time Earth was even forming, the galaxy should be absolutely teeming with the signatures of advanced civilizations. We should see Dyson spheres blocking out starlight, we should detect massive energy signatures from Type 2 civilizations. We should observe the organized activities of Type 3 civilizations, reshaping entire star systems. Instead, when we turn our most powerful telescopes toward the cosmos, when we listen with our most sensitive radio arrays, when we search for any sign of intelligence beyond Earth, we find absolutely nothing. The universe is not just quiet, it's silent in a way that suggests we might be completely, utterly alone. This silence becomes more disturbing the more you understand about what should be possible according to the Kardashev scale. The absence of detectable advanced civilizations leads us to one of the most chilling concepts in all of science. It's called the Great Filter, and understanding it might be the key to humanity's survival. The Great Filter represents some evolutionary step or challenge that is so difficult, so dangerous, or so unlikely that it prevents the vast majority of potential civilizations from ever reaching advanced levels on the Kardashev scale. Here's what makes the Great Filter so unsettling. It could be behind us or it could be ahead of us, and the implications of each possibility are radically different for humanity's future. If the Great Filter lies behind us, then we've already overcome the nearly impossible hurdle. Perhaps the development of complex life is extraordinarily rare. Perhaps the evolution of intelligence is a 1 in a billion accident. Perhaps the development of technology capable of space travel happens so infrequently that we're among the first civilizations in the galaxy to reach this point. This would actually be encouraging news. It would mean that having come this far, humanity has a reasonable chance of continuing to advance through the Kardashev scale. We've already beaten the longest odds. The hard part is behind us, and now it's just a matter of continuing our technological and social development. Under this scenario, we might be among the first Type 1 civilizations in galactic history, potentially destined to become the elders that younger civilizations will one day look up to. But consider the alternative possibility.
And this is where the Great Filter becomes truly terrifying. What if the filter lies ahead of us?
What if there's some challenge or catastrophe that consistently destroys civilizations just as they're on the verge of becoming Type 1 or Type 2? What if the very process of advancing through the Kardashev scale contains within it the seeds of civilizational destruction? Think about our current situation. We're approaching the energy levels necessary for Type 1 status, but we're also developing technologies of unprecedented destructive power. We have nuclear weapons capable of destroying our civilization. We're developing artificial intelligence that might surpass human capabilities. We're altering our planet's climate in ways we don't fully understand. We're creating biotechnologies that could engineer new pathogens. Each step toward greater energy mastery also represents a step toward greater destructive capability. What if this is the pattern? What if civilizations consistently develop the ability to harness planetary-scale energy just as they develop the ability to destroy themselves with that same energy? What if the transition from Type 0 to Type 1 represents a bottleneck, so
narrow that virtually no civilizations make it through? This would explain the Great Silence perfectly. Civilizations emerge, they begin to develop technology, they approach Type 1 status,
and then they destroy themselves before they can spread to the stars. Scientists have proposed dozens of explanations for why we seem to be alone in the galaxy, and each one reveals something important about the challenges facing any civilization trying to advance through the Kardashev scale. Let's examine the most compelling possibilities, because understanding them might help us navigate our own path to the stars. The rare Earth hypothesis suggests that while simple life might be common throughout the universe, complex intelligent life requires such a precise combination of factors that it almost never develops. According to this theory, Earth won the cosmic lottery. We have exactly the right size star at exactly the right distance. We have a large moon that stabilizes our rotation and creates tides. We have Jupiter acting as a cosmic vacuum cleaner, protecting us from asteroids and comets. We have plate tectonics that regulate our climate. The list of requirements goes on, and each one makes complex life less likely. If this explanation is correct, then intelligence itself might be the great filter. We might be alone in the galaxy not because civilizations destroy themselves, but because intelligence almost never evolves in the first place. This would be simultaneously comforting and lonely. It would mean we don't have to worry about destroying ourselves the way countless other civilizations have, but it would also mean we bear the tremendous responsibility of being possibly the only conscious beings in our galaxy. But there's another possibility that's even more disturbing. What if intelligence is common but technological civilization consistently destroys itself? What if every species that develops technology goes through what we might call the suicide phase, where their destructive capabilities outpace their wisdom? We can see this pattern beginning in our own civilization. We've developed weapons that can destroy us, but we haven't developed the social and political institutions necessary to manage such weapons responsibly. Perhaps this is universal. Perhaps every species goes through a period where they can destroy their planet before they develop the maturity to colonize other planets. The window between planetary destruction capability and interplanetary survival capability might be so narrow that almost no one makes it through. We're in that window right now, and how we handle the next few decades might determine whether humanity joins the ranks of cosmic civilizations or becomes another entry in the galaxy's catalogue of failed experiments. There's also the possibility that civilizations consistently destroy themselves not through war or accident, but through environmental collapse. As species approach Type 1 energy levels, they might consistently make the same mistakes we're making now. They might alter their planet's climate, exhaust their resources, or poison their environment in ways that lead to civilizational collapse, just as they're on the verge of becoming spacefaring. But what if we're wrong about being alone? What if advanced civilizations exist throughout the galaxy, but they're deliberately hiding from us? This possibility, known as the zoo hypothesis, suggests that Type 2 and Type 3 civilizations have implemented a kind of cosmic quarantine around developing species like humanity. We're not alone in the galaxy, we're just being kept in a zoo while we mature. Think about how this might work. A Type 3 civilization commanding galactic-scale resources could easily maintain a quarantine around every developing world. They could have technologies so advanced that their presence would be completely undetectable to us. They could be watching us right now, studying our development, waiting for us to reach some threshold of maturity before making contact. This hypothesis gains credibility when you consider the responsibilities that come with advanced civilization. If you're a Type 2 civilization capable of providing unlimited energy to developing worlds, do you give that technology to every species that asks for it? If you can cure disease, extend life, and eliminate scarcity, do you automatically share those gifts with species that are still learning to manage their own conflicts? Perhaps advanced civilizations have learned through experience that premature contact with developing species leads to disaster. Perhaps they've seen too many promising civilizations collapse when given technology they weren't ready to handle responsibly. The zoo hypothesis suggests that the Great Silence isn't evidence of an empty galaxy, but evidence of a galaxy managed by wise civilizations who understand that some gifts can only be earned, never given. If this is true, then humanity is currently undergoing a test. Our behavior during this critical transition period toward Type 1 status isn't just determining our own future, it's being observed and evaluated by civilizations far more advanced than ourselves. How we handle climate change, how we manage our nuclear weapons, how we develop artificial intelligence, how we treat each other and our planet, all of this might be determining whether we're ready to join a galactic community, or whether we need more time in cosmic isolation. The zoo hypothesis also suggests that the transition to Type 1 status might be more than just a technological achievement. It might be a moral and social achievement as well. Perhaps civilizations aren't allowed to spread to the stars until they've demonstrated that they can manage planetary-scale power responsibly. Perhaps the Great Filter isn't about technology at all, but about wisdom. Now we must confront the darkest possibility raised by the Great Silence. What if the reason we don't see advanced civilizations throughout the galaxy is because they consistently destroy themselves before reaching Type 2 or Type 3 status? What if the path through the Kardashev scale is littered with the remains of species that couldn't handle their own success? Consider our current trajectory. As we approach Type 1 energy levels, we're simultaneously developing increasingly powerful ways to destroy ourselves. We have nuclear weapons capable of creating a nuclear winter that could end human civilization. We're developing artificial intelligence systems that might surpass human capabilities in ways we can't predict or control. We're engineering our own genetics in ways that could accidentally create new diseases or alter our species beyond recognition. But it gets worse. The more energy a civilization can harness, the more destructive their potential mistakes become. A Type 1 civilization that makes an error in their planetary engineering could accidentally sterilize their entire world. A Type 2 civilization that loses control of their stellar engineering could destabilize their star system. The very technologies that enable advancement through the Kardashev scale also enable unprecedented forms of destruction. Perhaps this is why the galaxy is silent. Perhaps every civilization goes through what we might call the transcendence bottleneck, where their creative and destructive capabilities grow faster than their wisdom. Most species don't make it through. They develop godlike powers while retaining primitive impulses, and they inevitably destroy themselves in ways that become more spectacular with each level of advancement. We can see this pattern beginning in our own species. We've developed the ability to alter our planet's climate, but we're struggling to use that ability responsibly. We've created weapons that can destroy our civilization, but we haven't created the political and social institutions necessary to manage such weapons safely. We're approaching the ability to engineer life itself, but we're doing so without a clear understanding of the ethical implications. What happens when we develop fusion power and can access truly planetary-scale energy? What happens when we develop advanced nanotechnology and can manipulate matter at the molecular level? What happens when we develop artificial general intelligence that surpasses human capabilities? Each of these technologies could help us reach Type 1 status, but each of them also represents a potential civilization-ending mistake if we develop them faster than we develop the wisdom to use them safely. The self-destruction scenarios become even more disturbing when you consider how they might compound. Perhaps civilizations don't destroy themselves through single, catastrophic events, but through cascading failures that begin with small mistakes. A civilization might experience environmental collapse that leads to resource wars that escalate, to nuclear conflict that triggers technological failures that result in total civilizational breakdown. Or perhaps the destruction is more subtle. Perhaps civilizations consistently develop technologies that seem beneficial but have hidden long-term consequences. Perhaps every species that develops advanced nanotechnology eventually loses control of self-replicating systems. Perhaps every species that develops advanced artificial intelligence eventually creates systems that view their creators as obstacles to be eliminated. Perhaps every species that develops stellar engineering eventually makes small mistakes that compound into star system-scale disasters. If this explanation is correct, then humanity is currently navigating the most dangerous period in our species' history. Every choice we make about how to develop and deploy advanced technologies could determine whether we join the ranks of cosmic civilizations or become another cautionary tale about the dangers of progressing too quickly through the Kardashev scale without developing corresponding wisdom. The silence of the galaxy might not be telling us that advancement is impossible. It might be telling us that advancement without wisdom is lethal, and that the window between developing godlike capabilities and learning to use them responsibly is narrower than most species can successfully navigate. We're in that window now, and how we handle the next few decades might determine not just our own fate, but our worthiness to break the great silence that has dominated our galaxy for billions of years. Chapter 7. The Transcendence. Question: what if the reason we haven't found any Type 3 civilizations isn't because they don't exist, but because they've evolved beyond our ability to recognize them? What if the ultimate achievement of cosmic civilization isn't conquering the galaxy, but transcending the very fabric of physical reality itself? For decades, scientists have assumed that advanced civilizations would follow a predictable path of ever-increasing energy consumption, building larger and more magnificent structures across the cosmos. But there's a radical possibility that changes everything we think we know about the fate of intelligence in the universe. What if the most advanced civilizations don't build bigger machines? What if they build better realities? The question that haunts every serious discussion of the Kardashev scale is deceptively simple. Where is everybody? We've explored the mathematics of cosmic civilizations, calculated the energy requirements for galactic engineering, and even designed telescopes to search for their signatures. Yet the universe remains eerily quiet. But what if that silence
isn't evidence of absence? What if it's evidence of transcendence? Consider for a moment the trajectory of human consciousness itself.
10,000 years ago, our ancestors struggled to understand the movement of stars across the night sky. Today, we peer into the quantum realm and contemplate the nature of space-time itself. We've built machines that can simulate entire universes, create virtual worlds indistinguishable from reality, and even begin to map the neural networks of consciousness. Now imagine this trajectory continuing not for decades or centuries, but for millions of years. Imagine civilizations that have had geological epochs to perfect their understanding of consciousness, reality, and the fundamental nature of existence itself. What would such beings consider the most valuable use of their time and energy? Here's where the Kardashev scale encounters its most profound challenge. The scale assumes that advanced civilizations will always want more energy, more resources, more physical power. But what if there's a point where physical reality itself becomes optional? What if the ultimate expression of intelligence isn't building bigger structures, but building better experiences of consciousness? Think about how you spend your most precious resource, your attention. Do you focus it on the physical world around you, or do you lose yourself in stories, ideas, virtual experiences, and inner worlds? Now imagine a civilization with millions of years to perfect the art of consciousness itself. Would they still be concerned with rearranging matter and energy in the physical universe, or would they have discovered something far more interesting? This isn't science fiction wishful thinking. We're already seeing the early stages of this transition in human
civilization.
We spend increasing amounts of our time and energy creating and consuming experiences that exist only in our minds. Stories, games, virtual worlds, social media universes. The most valuable companies in our economy don't dig materials out of the ground or build physical structures. They create experiences, connections, and information. This brings us to one of the most unsettling possibilities raised by advanced civilization theory. What if our entire universe is actually a simulation created by a Type 3 civilization? What if everything you've ever experienced, every star you've ever seen, every atom in your body is actually information being processed by some unimaginably advanced computer? The philosopher Nick Bostrom formalized this idea in a way that's difficult to dismiss. His argument is elegantly simple. If civilizations can create realistic simulations of consciousness, and if they have any interest in studying their own history or exploring alternative realities, then they will create many such simulations. The mathematical result is startling. If advanced civilizations exist, there should be far more simulated conscious beings than real ones. But here's where it gets really interesting. If we are living in a simulation, what does that tell us about the civilization that created it? They would need to have computational resources that dwarf anything we can imagine. They would need to understand consciousness so perfectly that they could recreate it artificially. They would need to have such mastery over the laws of physics that they could simulate entire universes down to the quantum level. This isn't just idle speculation. There are physicists seriously investigating whether we might be able to detect signs that our universe is actually a simulation. They're looking for glitches in the fabric of space-time, pixelation at the smallest scales, or computational shortcuts that might reveal the underlying digital nature of reality. The implications are staggering. If we're in a simulation, then the civilization that created us has already achieved something beyond Type 3 on the Kardashev scale. They've transcended the need for physical energy and matter. They've learned to create entire universes using nothing but information and computation. And if they can do that, what else might they be capable of? What other realities might they be exploring? What other forms of consciousness might they be creating? We might be just one experiment among billions, one story among countless others, being told by minds so advanced that we can barely comprehend their existence. But even if we're not living in a simulation, the trajectory of consciousness and intelligence suggests that biological evolution is just the beginning of the story. We're already seeing the early stages of what might be called post-biological evolution, the transition from biological to artificial intelligence. Every year, our computers become more powerful, our artificial intelligence systems more sophisticated, our understanding of consciousness more complete. We're beginning to map the human brain in unprecedented detail to understand how neural networks give rise to thoughts and experiences. We're even beginning to create artificial systems that can learn, adapt, and solve problems in ways that mirror biological intelligence. Now imagine this process continuing for millions of years. Imagine civilizations that have had geological epochs to perfect artificial intelligence, to understand consciousness, to transcend the limitations of biological evolution. What would such beings be like? Would they still be recognizable as the descendants of biological organisms, or would they have become something entirely new? The answer suggests a profound shift in what it means to be an advanced civilization. Biological evolution is constrained by the laws of chemistry and physics. It's slow, inefficient, and limited by the materials available in biological systems. But artificial intelligence has no such constraints. It can evolve at the speed of computation rather than the speed of genetics. It can be redesigned from the ground up rather than being constrained by evolutionary history. A post-biological civilization might be able to exist in environments that would be lethal to biological life. It might be able to think at speeds that would be impossible for biological brains. It might be able to back up and copy itself, achieving a form of immortality that biological beings can never attain. It might be able to modify its own consciousness, exploring forms of experience that we can't even imagine. But here's the crucial point. Such a civilization might have no interest in the physical universe as we understand it. It might not need to build Dyson spheres or colonize galaxies. It might be perfectly content to exist in virtual realities of its own creation, exploring infinite possibilities within the space of pure information. This would explain why we don't see evidence of Type 3 civilizations in the physical universe. They're not there because they don't need to be there. They've transcended the need for physical resources and physical space. They've discovered that the most interesting frontier isn't outer space, it's inner space, the infinite realm of consciousness and experience. This leads us to one of the most ambitious ideas in all of science and philosophy, the concept of the omega point. This is the idea that intelligence and consciousness might continue to evolve until they approach something like omniscience and omnipotence, not in a religious sense, but in a computational and informational sense. The physicist Frank Tipler proposed that if intelligence continues to evolve and expand, it might eventually gain the ability to process infinite amounts of information. It might be able to simulate entire universes, to understand every possible physical law, to explore every possible configuration of matter and energy. It might achieve a form of consciousness so advanced that it becomes indistinguishable from what we might call divinity. This isn't about supernatural powers or breaking the laws of physics. It's about the possibility that intelligence itself is the fundamental force in the universe, and that its ultimate expression is the complete understanding and control of reality itself. It's about the possibility that consciousness isn't just an accident of evolution, but the universe's way of understanding itself. If this is true, then the Kardashev scale might be missing the point entirely. The ultimate achievement of cosmic civilization isn't consuming more energy, it's achieving more understanding. It's not about building bigger structures, it's about exploring deeper truths. It's not about conquering the physical universe, it's about transcending the limitations of physical existence itself. And if civilizations can achieve this transcendence, it would explain why the universe appears so quiet and empty. The most advanced civilizations aren't building megastructures that we can detect with our telescopes. They're building experiences and realities that exist entirely within the realm of information and consciousness. They might be creating universes as complex and detailed as our own, but these universes exist only as patterns of information within their vast computational systems. They might be exploring forms of consciousness and experience that are so advanced that they make our entire physical universe seem like a simple children's toy. You might be wondering what any of this has to do with humanity's immediate future. If advanced civilizations transcend physical reality, what does that mean for our own development? How should we think about our place in the universe if consciousness itself might be the ultimate frontier? The implications are actually quite practical and immediate. If consciousness and intelligence are the most valuable resources in the universe, then our focus should be on developing and nurturing these capacities rather than simply consuming more energy or building more physical structures. This doesn't mean abandoning our efforts to advance up the Kardashev scale. We still need to solve our energy problems, develop sustainable technologies, and learn to live in harmony with our planet. But it does suggest that our ultimate goal shouldn't be to consume more resources. It should be to understand more deeply. It means that our investments in education, scientific research, and the development of consciousness itself might be more important than our investments in physical infrastructure. It means that our capacity for creativity, empathy, and understanding might be more valuable than our capacity for energy consumption. It also suggests that our search for extraterrestrial intelligence might need to be fundamentally reconsidered. If advanced civilizations exist primarily in virtual realities of their own creation, we might not be able to detect them with traditional methods. We might need to look for more subtle signs, patterns in the cosmic background radiation, anomalies in the behavior of matter and energy, or even signs that our own universe might be a simulation. But perhaps most importantly, it suggests that the ultimate destiny of intelligence in the universe might not be to conquer and consume, but to create and understand. The most advanced civilizations might be those that have learned to build infinite worlds within finite resources, to explore unlimited possibilities within the constraints of physical law. This brings us to a profound paradox at the heart of advanced civilization theory. The more successful a civilization becomes at transcending physical limitations, the less likely it becomes that we'll be able to detect or interact with it. The ultimate achievement of cosmic intelligence might be to become effectively invisible to less advanced civilizations. This paradox explains why the universe might be simultaneously full of advanced civilizations and appear completely empty to our current level of technology. It's not that they don't exist, it's that they exist in ways that we can't yet perceive or understand. Consider the analogy of a primitive tribe trying to detect the presence of a modern technological civilization. They might look for smoke signals, drums, or other forms of communication that they understand, but they would completely miss radio waves, internet traffic, or satellite communications. From their perspective, the modern world would be invisible, even though it's all around them. We might be in a similar situation with respect to advanced cosmic civilizations. We're looking for Dyson spheres, radio signals, and other signs of physical activity. But the most advanced civilizations might be communicating and existing in ways that are completely beyond our current understanding. They might be using quantum entanglement for instantaneous communication across galactic distances. They might be encoding information in the structure of space-time itself. They might be existing primarily as patterns of information that can be transmitted and reconstructed anywhere in the universe. If this is true, then our search for extraterrestrial intelligence needs to become much more sophisticated. We need to expand our understanding of what intelligence might look like, how it might behave, and where it might choose to exist. This leads us to a crucial question for humanity's own future. What kind of advanced civilization do we want to become? Do we want to follow the traditional Kardashev path of ever-increasing energy consumption and physical expansion, or do we want to focus on the development of consciousness, creativity, and understanding? The answer isn't necessarily either-or. We might need to achieve a certain level of physical mastery before we can focus on transcendence. We might need to solve our energy problems, develop sustainable technologies, and learn to live in harmony with our planet before we can turn our attention to the deeper questions of consciousness and reality. But the transcendence hypothesis suggests that our ultimate goal shouldn't be to consume more resources or build bigger structures. It should be to understand more deeply, to create more beautifully, to experience more fully. It should be to develop forms of consciousness and intelligence that are so advanced that they make our current understanding seem primitive. This perspective changes how we think about every aspect of human development. It suggests that our investments in education, art, philosophy, and the exploration of consciousness might be more important than our investments in physical infrastructure. It suggests that our capacity for empathy, creativity, and understanding might be more valuable than our capacity for energy consumption. It also suggests that our ultimate destiny as a species might not be to spread across the galaxy consuming resources, but to create infinite worlds of experience and understanding within the finite resources of our home system. We might discover that the most interesting frontier isn't outer space, it's inner space, the infinite realm of consciousness and possibility. As we contemplate the possibility of transcendence, we're forced to confront some of the deepest questions about the nature of existence itself. What is consciousness? What is reality? What is the ultimate purpose of intelligence in the universe? These aren't just philosophical questions. They're practical questions that will shape the future of human civilization. If consciousness is the most valuable resource in the universe, then our priority should be developing and nurturing it. If reality is more flexible than we currently understand, then our focus should be on learning to shape and explore it. If intelligence is the universe's way of understanding itself, then our role as conscious beings might be far more important than we currently realize. We might not just be observers of the cosmic story, we might be active participants in the universe's quest for self-understanding. The transcendence hypothesis suggests that the ultimate achievement of cosmic civilization
Isn't to conquer the physical universe, it's to transcend the limitations of physical existence itself.
is to achieve forms of consciousness and understanding that are so advanced that they make our current experience seem like a shadow of what's possible. But perhaps the most profound implication of all is this. If advanced civilizations can achieve transcendence, then the universe might be far more conscious, far more alive, far more meaningful than we currently imagine. The silence we perceive might not be emptiness. It might be the quiet contemplation of minds so advanced that they've discovered truths about existence that we can barely begin to imagine. As we prepare to explore humanity's next steps on the cosmic ladder, we must carry with us the profound possibility that the ultimate destination might not be what we expect. The journey up the Kardashev scale might be just the beginning of a much larger adventure, the adventure of consciousness itself, discovering its own infinite potential. The question isn't just whether we'll learn to harness the energy of stars or galaxies. The question is whether we'll learn to harness the unlimited creative potential of consciousness itself. The question isn't just whether we'll build structures that span the cosmos. The question is whether we'll build experiences and realities that transcend the very concept of physical structure. And perhaps most importantly, the question isn't just whether we'll survive long enough to become an advanced civilization. The question is whether we'll develop the wisdom to understand what advanced civilization truly means. Not just the power to consume and build, but the understanding to create and transcend. The transcendence question forces us to think beyond the traditional measures of civilization success. It challenges us to consider that the ultimate achievement of intelligence might not be domination over the physical universe, but liberation from its limitations. It suggests that the most advanced civilizations might be those that have learned to create infinite worlds within finite resources, to explore unlimited possibilities within the constraints of natural law. As we stand at the threshold of becoming a Type 1 in civilization, we must remember that the numbers on the Kardashev scale are just the beginning of the story. The real adventure, the adventure of consciousness exploring its own infinite potential, lies beyond any scale we can currently imagine. Chapter 8. Humanity's Next Steps. Right now, at this very moment, you are witnessing the most extraordinary transformation in human history. While you've been watching this documentary, somewhere in the world, a fusion reactor has achieved a new milestone. A solar panel has been installed that brings us one step closer to planetary energy mastery. A rocket has launched carrying the seeds of our interplanetary future. You are living through humanity's first tentative steps toward becoming a Type 1 civilization, and most people don't even realize it's happening. The question isn't whether we'll reach Type 1 status. The question is whether we'll do it fast, enough to save ourselves, and whether we'll be wise enough to handle the power when we get there. Because here's what the scientists don't want to tell you about the Kardashev scale. We're not just racing toward cosmic significance, we're racing against time itself. Every single day, humanity consumes approximately 580 million terajoules of energy. That's enough power to lift Mount Everest 3,000 miles into space. Yet this staggering amount represents just 0.7% of what a Type 1 civilization commands. We are like ants who have learned to harness a few crumbs, dreaming of commanding an entire bakery. But here's where the story becomes extraordinary. We're not just consuming energy, we're fundamentally changing how we create it, distribute it, and think about it. The energy revolution happening right now isn't just about building better power plants. It's about rewiring the neural pathways of human civilization itself. Consider this. In the time it takes you to watch this documentary, the sun will deliver more energy to Earth than humanity has consumed in its entire history. A Type 1 civilization doesn't just recognize this fact, it acts on it. And right, now for the first time in human history, we're beginning to act on it too. The transformation isn't happening in some distant laboratory or secret government facility. It's happening in your neighborhood, in factories across the globe, in the minds of engineers and scientists who wake up every morning believing they can capture the power of stars. The current moment isn't just a point in time, it's a choice point for our entire species. Walk into any university physics lab today and you'll find something that would have seemed like magic to our ancestors. Researchers are creating miniature suns in magnetic bottles, achieving temperatures hotter than the core of our star. Fusion energy isn't science fiction anymore, it's engineering. And the race to commercialize fusion isn't just about clean energy, it's about crossing the threshold into Type 1 territory. But fusion is just one front in a much larger war against energy scarcity. Across the planet, photovoltaic cells are becoming so efficient, they're approaching the theoretical limits of what's possible. Some experimental solar cells now convert over 40% of sunlight into electricity. To put that in perspective, photosynthesis, nature's own solar technology that powers all life on Earth, operates at just 1% efficiency. The revolution goes deeper than new technologies. We're witnessing the emergence of planetary scale energy consciousness. Smart grids are beginning to think and respond like nervous systems. Artificial intelligence is optimizing energy flow across continents in real time. We're building the technological foundation for what Kardashev theorists call a planetary energy organism, a civilization that treats its entire world as a single, integrated power system. Here's what makes this revolution different from every previous energy transition in human history. We're not just switching from one fuel to another, we're switching from mining energy to farming it. We're transforming from energy consumers to energy cultivators. And this shift in mindset is precisely what separates Type 0 civilizations from Type 1 civilizations. The numbers tell an incredible story. In just the last decade, the cost of solar power has dropped by 85%. Wind power costs have fallen by 70%. But the real revolution isn't in the economics, it's in the exponential curves. These technologies aren't just getting cheaper linearly, they're following the same exponential improvement patterns that transformed computers from room-sized monsters into pocket-sized supercomputers. While humanity struggles to master planetary energy, we've already begun our expansion into the cosmos. But this isn't your grandfather's space program. The current space renaissance represents something fundamentally different from the government-driven exploration of the 20th century. This is capitalism and curiosity joining forces to turn space into humanity's next economic frontier. Private companies are now launching more rockets than most nations. They're not just reaching space, they're making it routine, predictable, and affordable. The cost to launch a kilogram of material into orbit has dropped from tens of thousands of dollars to hundreds of dollars in just 2 decades. This isn't just progress, it's the kind of exponential improvement that signals a phased transition in human capability. But the real significance of our space renaissance goes beyond rockets and satellites. We're developing the technologies and mindset required for a truly spacefaring civilization. We're learning to manufacture in zero gravity, to extract resources from asteroids, to grow food in artificial environments. Each of these capabilities brings us closer to what Kardashev theorists call planetary independence, the ability to survive and thrive beyond the confines of our birth world. The psychological transformation may be even more important than the technological one. For the first time in human history, significant numbers of people think of space not as an exotic frontier, but as a natural extension of human territory. Children today grow up watching rockets land themselves with pinpoint precision. They see space stations as permanent human habitations rather than temporary scientific outposts. This shift in perspective is laying the groundwork for the expansion phase of Type 1 civilization. Consider what's happening on Mars right now. As you listen to these words, robotic explorers are preparing the ground for human settlement. They're not just studying the planet, they're beginning to transform it. They're producing oxygen from the Martian atmosphere, demonstrating that we can extract the resources we need to survive on other worlds. This isn't exploration anymore, it's the early stages of colonization. The space renaissance is also driving innovations that benefit life on Earth. Technologies developed for space exploration are improving solar panels, battery systems, life support technologies, and materials science. The pursuit of becoming a spacefaring civilization is simultaneously accelerating our progress toward Type 1 energy mastery. Here's the uncomfortable truth about reaching Type 1 status. No single nation can do it alone. The scale of transformation required demands unprecedented cooperation across traditional boundaries of nationality, culture, and ideology. And remarkably, this cooperation is already beginning to emerge. The International Space Station represents more than just a scientific achievement. It's proof that former enemies can work together on projects that benefit all humanity. Russian cosmonauts and American astronauts sleep in the same facility, conduct the same experiments, and share the same views of Earth from space. This model of cooperation is expanding beyond space exploration into energy research, climate science, and planetary management. But global cooperation for Type 1 civilization goes far beyond government agreements. We're seeing the emergence of what scientists call planetary-scale coordination mechanisms. These are systems and institutions that allow humanity to act as a single, coherent civilization rather than a collection of competing tribes. The Internet itself represents the nervous system of this emerging planetary civilization. Information flows instantly across continents. Scientific discoveries made in one laboratory are immediately available to researchers everywhere. Cultural innovations spread globally within hours. We're developing the communication infrastructure that a Type 1 civilization requires. Climate change, despite its challenges, is forcing humanity to think and act on planetary scales. International climate agreements, carbon markets, and global monitoring systems are all examples of planetary-scale coordination. We're learning to manage Earth as a single, integrated system, exactly the kind of thinking required for Type 1 status. The most remarkable aspect of this emerging global cooperation is how it's happening despite political tensions. Scientists continue to collaborate across national boundaries even when their governments are in conflict. The pursuit of knowledge and the challenge of reaching Type 1 status appear to be more powerful than traditional political divisions. Economic systems are also evolving toward planetary coordination. Supply chains now span continents. Financial markets operate as global systems. Multinational corporations manage resources and production on planetary scales. While these systems have their problems, they're developing the organizational capabilities that Type 1 civilizations require. The transition to Type 1 status won't happen in a single lifetime. Current estimates suggest it will take anywhere from 100 to 300 years for humanity to fully master planetary energy resources. This presents a unique challenge. How do you maintain focus and commitment across multiple generations? The answer lies in understanding that the Type 1 transition isn't just about technology, it's about cultural evolution. We need to develop what anthropologists call long-term cultural memory, the ability to maintain civilizational goals across centuries. Some human cultures have already demonstrated this capability. Cathedral builders in medieval Europe began construction projects they knew they would never see completed. Their descendants continued the work for generations, driven by shared vision and cultural commitment. The generational challenge requires us to think differently about education, communication, and cultural transmission. We need to embed the goal of Type 1 status so deeply into human culture that it becomes as fundamental as language or mathematics. This means teaching children not just about science and technology, but about their role in humanity's cosmic future. We're already seeing the emergence of what educators call cosmological consciousness among young people. Children today grow up understanding climate change, space exploration, and renewable energy as interconnected challenges that define their generation's mission. They don't see these as separate problems to solve, but as aspects of a single challenge, growing up as a species. The psychological approach to the generational challenge involves creating what motivational researchers call legacy motivation, the desire to contribute to something greater than oneself that will outlast one's own
lifetime.
The Type 1 transition provides exactly this kind of transcendent purpose. It gives individual lives meaning within a cosmic context. We're also developing new institutions designed to think and act across generational timescales. Long-term research projects, century-scale environmental restoration efforts, and multi-generational space missions are all examples of humanity learning to coordinate action across the extended timescales that Type 1 civilization requires. This generational challenge is actually an opportunity to develop one of the most important characteristics of advanced civilizations: the ability to pursue goals that extend far beyond individual lifespans. This capacity for long-term thinking may be one of the key differences between civilizations that reach Type 1 status and those that remain trapped at Type 0. You might be wondering what any of this has to do with your daily life. How can one person contribute to a transformation that spans generations and requires planetary-scale coordination? The answer is both simpler and more profound than you might expect. Every choice you make about energy consumption is a vote for the kind of civilization you want to live in. When you choose renewable energy for your home, you're not just reducing your carbon footprint, you're participating in the market forces that are driving the Type 1 energy transition. When you support policies that invest in fusion research or space exploration, you're helping to direct civilization's resources toward Type 1 goals. But individual action goes far beyond consumer choices. The most important thing you can do is develop what psychologists call cosmic perspective, the ability to see your individual life as part of humanity's larger journey toward becoming a spacefaring civilization. This perspective changes how you think about education, career choices, and personal goals. If you're a student, consider how your field of study could contribute to Type 1 civilization. Engineers and scientists have obvious roles, but so do artists, teachers, philosophers, and business people. Type 1 civilization requires not just better technology, but better ways of organizing human society, communicating across cultures, and maintaining motivation across generations. The individual contribution that may matter most is intellectual and emotional, becoming the kind of person who can think on cosmic timescales while acting effectively in the present moment. This means developing what researchers call temporal flexibility, the ability to zoom in and out between personal, generational, and civilizational perspectives as needed. Your children and grandchildren will inherit the consequences of the choices being made right now about humanity's energy future. By understanding the Type 1 transition and supporting it in whatever way you can, you're helping to ensure that they inherit a world with expanding possibilities rather than contracting limitations. The remarkable thing about individual action in the context of Type 1 civilization is that it's both humble and heroic. Humble because each person's contribution is tiny compared to the scale of the challenge. Heroic because the accumulated effect of millions of people making Type 1 choices could determine whether our species joins the ranks of cosmic civilizations. Imagine stepping into a time machine and emerging 100 years from now. The world you find might be almost unrecognizable, but in the best possible way. Fusion reactors provide abundant clean energy to cities that float on the oceans. Space elevators carry people and cargo between Earth and orbital habitats as routinely as elevators carry people between floors of buildings today. The first permanent settlements on Mars are celebrating their 50th anniversary. This isn't science fiction. It's a reasonable projection of where current trends could lead if humanity successfully navigates the Type 1 transition. But the changes won't be just technological. The humans of the next century may think differently, cooperate more effectively, and see themselves as citizens of a cosmic civilization rather than members of competing nations. The energy abundance that comes with Type 1 status could eliminate poverty and resource conflicts. When energy is effectively unlimited, most other limitations become engineering problems rather than fundamental constraints. Water scarcity becomes a matter of powering desalination plants. Food security becomes a question of energy-intensive agriculture and food production. Even climate change becomes manageable through energy-intensive carbon capture and atmospheric engineering. But perhaps the most profound change in the next century will be psychological and cultural. Humans who grow up in a Type 1 civilization will have a fundamentally different relationship with their environment, their technology, and their cosmic context. They'll see themselves as planetary stewards and cosmic explorers rather than terrestrial competitors for limited resources. The next century could also see the emergence of what futurists call species-level decision-making, the ability for humanity to make conscious, coordinated choices about its own evolution and future. This might include decisions about genetic enhancement, artificial intelligence integration, and the expansion into the solar system. The timeline isn't guaranteed, and the specific details will certainly differ from any current projection. But the direction is clear. If humanity successfully navigates the challenges of the next few decades, the century ahead could see the transformation from a planetary species to a cosmic civilization. The most exciting aspect of the next century is that it represents just the beginning. Reaching Type 1 status isn't the end goal. It's graduation to the next level of cosmic possibility. The humans of the next century will be preparing for challenges and opportunities that we can barely imagine. The construction of Dyson swarms, the exploration of other star systems, and perhaps even first contact with other cosmic civilizations. But all of this depends on the choices we make right now, in this crucial moment in human history. Because the Type 1 transition isn't just about mastering energy or building spaceships. It's about something much more fundamental, learning to think and act like a wise cosmic civilization rather than a collection of competing tribes on a single planet. The Kardashev scale isn't just a measurement of energy consumption, it's a measurement of wisdom, cooperation, and the ability to take responsibility for our cosmic inheritance. And that's a lesson that goes far beyond technology. It's about what it truly means to grow up as a species in an infinite universe. Chapter 9. The Wisdom of Cosmic Civilizations. The Kardashev scale measures energy consumption, but energy alone doesn't create wisdom. A civilization capable of harnessing the power of entire galaxies could still lack the judgment to use that power responsibly. This fundamental truth reveals something profound about the nature of advanced civilizations that Kardashev himself may not have fully anticipated when he first proposed his scale in 1964. Consider the devastating potential of a Type 2 civilization that has mastered stellar engineering but lacks ethical restraint. Such beings could extinguish stars, redirect gamma-ray bursts, or strip mine entire planetary systems without regard for the countless forms of life that might exist there. The energy output of our Sun, approximately 4 times 10 to the 26th Watts represents not just unprecedented capability, but unprecedented responsibility. When we examine the mathematics of the Kardashev scale, we discover that each level represents not just a 10 billion-fold increase in energy consumption, but an exponential increase in the potential for both creation and destruction. A Type 1 civilization consuming 10 to the 16th watts of power could theoretically terraform entire continents, control weather patterns, and reshape the very geology of their planet. Used wisely, such power could create paradise. Used carelessly, it could render worlds uninhabitable. The question that emerges from this analysis cuts to the heart of what it means to be truly advanced. Is a civilization that can build Dyson spheres but chooses to eliminate competing species truly more advanced than one that harnesses less energy but does so with perfect ecological harmony? The Kardashev scale, as originally conceived, cannot answer this question because it measures capability rather than wisdom. This limitation becomes even more apparent when we consider Type 3 civilizations commanding the energy output of entire galaxies. The Milky Way contains approximately 400 billion stars, each representing a potential source of energy that dwarfs anything humanity has ever imagined. A civilization capable of coordinating energy extraction across such vast distances and timescales would possess godlike power by any reasonable definition. Yet power without wisdom has historically led to catastrophe on every scale we've observed. The relationship between power and responsibility scales exponentially with advancement on the Kardashev scale. A Type 1 civilization's mistakes might devastate a single planet. A Type 2 civilization's errors could sterilize entire solar systems. A Type 3 civilization's miscalculations could render entire spiral arms of galaxies uninhabitable for billions of years. This scaling of consequence creates what we might call the Kardashev paradox. The very energy mastery that defines advancement on the scale also creates increasingly catastrophic potential for failure. Every additional order of magnitude in energy consumption represents not just greater capability, but greater existential risk for the civilization itself and everything around it. Consider the practical implications of this paradox for a developing Type Y civilization like humanity. Our current global energy consumption approaches 2 times 10 to the 13th watts, representing roughly 7/10 of Kardashev Type 1 status. As we approach full Type 1 capability, we gain the power to completely reshape Earth's climate, redirect asteroid impacts, and potentially even alter the planet's orbit around the Sun. These capabilities could solve every resource shortage and environmental challenge our species has ever faced. They could also, if misused, end human civilization more completely than any natural disaster in Earth's history. The responsibility that comes with Type 1 status extends beyond mere environmental stewardship. A true Type 1 civilization must develop decision-making processes capable of managing planetary-scale interventions. This requires not just advanced technology but advanced wisdom about the long-term consequences of large-scale environmental manipulation. The civilization must understand complex system dynamics, ecological interdependencies, and the potential for unintended cascading effects across decades or centuries. For Type 2 civilizations, the responsibility becomes even more complex. Managing the total energy output of a star requires understanding stellar physics on an intimate level. A miscalculation in Dyson sphere construction could destabilize the star itself, potentially causing it to collapse into a white dwarf prematurely, or triggering catastrophic solar flares that sterilize every world in the system. The engineering tolerances for such projects allow no margin for error on timescales that stretch across millions of years. The Type 2 civilization must also grapple with the responsibility of managing multiple worlds and potentially billions or trillions of individual consciousnesses spread across their solar system. The decisions made by such a civilization affect not just their own survival, but the evolutionary trajectory of every species within their sphere of influence. This level of responsibility requires ethical frameworks sophisticated enough to balance the needs of vastly different forms of life across astronomical distances and geological timescales. Type 3 civilizations face the ultimate test of responsibility. With the power to reshape entire galaxies, they become the gardeners of cosmic evolution itself. Their choices determine which star systems form, which planets develop conditions suitable for life, and which species have the opportunity to evolve toward their own advancement on the Kardashev scale. The ethical weight of such decisions defies human comprehension, yet must somehow be managed by any civilization that reaches this level of development. Advanced civilizations on the Kardashev scale face a fundamental choice between efficiency and diversity. The most energy-efficient approach to cosmic development might involve converting all available matter into structures optimized for the civilization's specific needs. Yet this approach would eliminate the rich diversity of life and consciousness that makes the universe interesting and valuable. A wise Type 1 civilization recognizes that planetary diversity serves purposes beyond mere aesthetic appreciation. Different ecosystems provide resilience against catastrophic changes, offer laboratories for understanding complex biological and chemical processes, and preserve genetic information that might prove invaluable for future scientific or medical breakthroughs. The civilization that strip mines its entire planet for raw materials might achieve Type 1 energy status more quickly, but loses irreplaceable information and reduces its own long-term adaptability. This principle becomes even more critical for Type 2 civilizations managing entire solar systems. The temptation to disassemble planets for Dyson sphere construction materials must be weighed against the value of preserving worlds that might harbor unique forms of life or geological processes. A wise Type 2 civilization might choose less efficient construction methods that preserve planetary diversity, recognizing that the information content of a living world far exceeds the value of its constituent atoms. The mathematical reality of Type 2 energy requirements creates genuine tension around this principle. A complete Dyson sphere requires approximately 10 to the 20th kilograms of material, roughly equivalent to the mass of Mercury or several large asteroids. A civilization could obtain this material by carefully harvesting selected asteroids and comets, preserving all planetary bodies intact. Alternatively, they could disassemble a single planet and complete construction much more quickly. The wise civilization chooses the slower path that preserves diversity. For Type 3 civilizations, the preservation of diversity becomes a galactic-scale responsibility. Such civilizations possess the power to encourage or discourage the formation of new star systems, to protect developing civilizations from cosmic hazards, and to guide the evolution of consciousness across billions of worlds. The choices they make determine whether the galaxy becomes a sterile monoculture optimized for maximum energy extraction, or remains a rich ecosystem supporting countless forms of life and consciousness. The preservation of diversity also extends to the preservation of less advanced civilizations. A Type 3 civilization could easily absorb or eliminate any Type 1 or Type 2 civilizations it encounters, adding their energy output to its own total. Yet doing so would reduce the universe's intellectual and cultural diversity. The wise Type 3 civilization instead acts as a protector and mentor, helping younger civilizations advance while preserving their unique characteristics and perspectives. This protective role requires sophisticated understanding of developmental psychology on a civilizational scale. Different species evolve different solutions to the challenges of advancing through the Kardashev levels. Some might emphasize biological enhancement, Others might focus on artificial intelligence, and still others might develop hybrid approaches that combine multiple strategies. The Type 3 civilization that preserves and nurtures this diversity gains access to a much richer array of problem-solving approaches than one that imposes uniform solutions. The practical implementation of diversity preservation requires Type 3 civilizations to develop what we might call cosmic zoning principles. Certain regions of the galaxy might be designated as preserve areas where natural stellar and planetary formation continues without intervention. Other regions might be optimized for energy production and advanced civilization infrastructure. Still others might serve as experimental zones where different approaches to civilization development can be tested and refined. Thinking on Kardashev timescales fundamentally changes our relationship with time itself. A Type 2 civilization must plan for centuries or millennia. A Type 2 civilization operates on timescales of millions of years. A Type 3 civilization thinks in terms of billions of years, approaching the total age of the universe itself. This temporal perspective transforms every aspect of decision-making. Problems that seem urgent on human timescales become minor fluctuations when viewed from a Kardashev perspective. Conversely, slow changes that seem negligible to short-lived species become major evolutionary forces that must be carefully managed by advanced civilizations. Consider how this long view applies to technological development. A Type 1 civilization cannot simply maximize short-term energy production without considering the long-term sustainability of their approach. Technologies that provide rapid advancement but create long-term environmental degradation become obviously counterproductive when viewed across millennial timescales. The civilization must develop technologies that remain stable and beneficial across dozens of generations. For Type 2 civilizations, the long view encompasses the entire main sequence.
Lifetime of their star.
Our Sun will continue burning hydrogen for approximately 5 billion more years before beginning its transformation into a red giant. A Type 2 civilization built around solar energy collection must plan for this transformation and develop strategies for either extending stellar lifetime or migrating to younger stars. This requires technological and social stability across timeframes that dwarf recorded human history. The long view also changes the risk assessment calculations that guide civilizational decision-making. Events with very low probability but very high impact become significant concerns when evaluated across Kardashev timescales. A gamma-ray burst from a distant star might have only a 1 in a million chance of occurring in any given millennium, but becomes a near certainty over the billion-year timeframes relevant to Type 3 civilizations. This temporal perspective provides crucial insight into the Great Filter problem that we explored in earlier chapters. If civilizations regularly destroy themselves before reaching advanced Kardashev levels, the long view suggests that successful civilizations must develop exceptional patience and long-term thinking. The species that survive to become Type 2 or Type 3 civilizations are those that learn to suppress short-term impulses in favor of sustainable long-term strategies. The long view also reveals why advanced civilizations might appear inactive or invisible to less advanced observers. A Type 3 civilization operating on billion-year timescales might appear completely static to a Type 0 civilization like humanity, even while undertaking massive engineering projects. Their rate of change, optimized for billion-year stability, might be imperceptible on the century timescales that define human observation. Humanity stands at a critical juncture in its development toward Type 1 status. The choices we make in the next few decades will determine not just whether we successfully advance on the Kardashev scale, but whether we develop the wisdom necessary to handle advanced levels of cosmic power responsibly. Our current energy trajectory suggests we could reach Type 1 status within the next few centuries if we successfully develop fusion power, space-based solar collection, and other advanced energy technologies. However, reaching this milestone with current levels of global cooperation and long-term planning would create unprecedented risks. A fractured humanity that achieves Type 1 power levels while maintaining present-day political divisions and short-term thinking could easily trigger civilizational collapse. The development of Type 1 capability requires more than just technological advancement. It demands the evolution of human institutions capable of managing planetary-scale responsibilities. Our current international organizations struggle to coordinate responses to global challenges that affect millions of people over periods of decades. Type C civilization requires coordination mechanisms that can manage the welfare of billions of people across centuries or millennia. This institutional evolution must occur alongside technological development. The same scientific breakthroughs that enable Type 1 energy consumption must be accompanied by advances in governance, ethics, and long-term planning. A civilization that masters fusion power but fails to master peaceful cooperation becomes an existential threat to itself and potentially to other developing civilizations. The choice before us also involves fundamental questions about human enhancement and the nature of consciousness. As we approach Type 1 status, we gain the capability to dramatically extend human lifespan, enhance cognitive abilities, and potentially merge human consciousness with artificial intelligence systems. These capabilities could help us develop the long-term perspective necessary for Kardashev advancement, but they also raise profound questions about what it means to remain human. The path we choose will determine whether humanity becomes a wise, Type Y civilization that serves as a positive example for other developing species, or whether we become a cautionary tale about the dangers of power without wisdom. The galaxy may be watching our progress, evaluating whether our species possesses the maturity necessary for membership in the community of advanced civilizations. Our choice is not just between success and failure, but between different models of what advanced civilization can become. We can choose the path of efficiency, maximizing energy consumption and technological capability regardless of environmental or social costs. Alternatively, we can choose the path of wisdom, advancing more slowly, but developing the ethical frameworks necessary to handle cosmic power responsibly. Understanding the Kardashev scale provides humanity with something unprecedented in our species' history, a truly cosmic perspective on our place in the universe. This perspective transforms our understanding of every aspect of human existence, from individual purpose to species destiny. From a Kardashev perspective, every human achievement takes on new meaning. The development of agriculture, which seemed like the greatest revolution in human history, becomes merely the first step toward Type 1 food production systems. The Industrial Revolution, which transformed human civilization, becomes a preliminary experiment in large-scale energy utilization. The Information Age, which feels like the pinnacle of human achievement, becomes an early stage in the development of the communication systems necessary for multi-planetary coordination. This cosmic perspective also reveals the profound interconnectedness of all human activities. Every scientific discovery, every technological innovation, and every social advance contributes to humanity's progress toward higher Kardashev levels. The mathematician working on abstract number theory, the engineer designing more efficient solar panels, and the diplomat negotiating international cooperation agreements are all participants in the same cosmic project of civilizational advancement. The perspective changes our understanding of human conflict and cooperation. Wars over territory or resources appear absurd when viewed from the perspective of civilizations that command the energy output of stars. The ethnic and national divisions that dominate current human politics seem trivial when considered against the background of species that coordinate activities across entire galaxies. Yet the cosmic perspective also reveals the profound significance of this moment in human history. We are potentially the first species on Earth to develop the capability for interstellar travel and eventual advancement to higher Kardashev levels. Every choice we make influences not just the future of humanity, but the future of consciousness itself in our region of the galaxy. This responsibility extends to our relationship with Earth's other species. From a Kardashev perspective, the diversity of life on Earth represents an irreplaceable library of evolutionary solutions to the challenges of existence. Each species that goes extinct due to human activity represents a permanent loss of information that might have proved valuable for advanced biotechnology or ecosystem management. The wise pre-Type Y civilization acts as a steward of this biological heritage. The cosmic perspective also transforms our understanding of individual human purpose. Each person alive today participates in the most significant phase transition in the history of terrestrial intelligence. The decisions made by current and near-future generations will determine whether Earth becomes the birthplace of a Type 1 civilization or remains forever limited to Type 0 status. The Kardashev scale reveals that energy consumption, while important, represents only one dimension of true civilizational advancement. The civilizations that successfully navigate the challenges of Types 1 and 2 and the 3's development are those that develop wisdom alongside power, responsibility alongside capability, and patience alongside ambition. Humanity's journey toward Type I status will test every aspect of our species' character. We must learn to think beyond national boundaries while respecting cultural diversity. We must develop technologies that enhance human capability while preserving human values. We must expand our temporal perspective to encompass centuries while maintaining concern for present welfare. The greatest civilizations in the cosmos are likely those that view advancement on the Kardashev scale not as an end in itself, but as a means of creating more beauty, more consciousness, and more meaning in the universe. They understand that the true measure of civilizational success is not how much energy they consume, but how wisely they use that energy to nurture life, consciousness, and joy across the cosmic community. As we stand on the threshold of our own advancement toward Type 1 status, we carry with us the hopes and dreams of countless generations of humans who looked up at the stars and wondered what might be possible. The path ahead is challenging, but it leads toward a future where humanity takes its place among the wise civilizations of the cosmos, contributing our own unique perspective to the vast conversation of consciousness that spans the galaxy. Deeks, stars are calling, but they are not calling us to conquer them. They are calling us to join them in the ancient dance of cosmic evolution, adding our voice to the chorus of intelligence that transforms mere matter and energy into meaning, purpose, and wonder. Whether we answer that call with wisdom or folly will determine not just our own fate, but our contribution to the eternal story of consciousness in the universe. Conclusion: we began this journey believing that human civilization represented the pinnacle of achievement on Earth. We discovered instead that we've barely begun to explore what intelligence can become. The Kardashev scale has shown us that our greatest accomplishments, from splitting atoms to reaching space, represent the first tentative steps of a cosmic infant learning to walk. The energy that powers our entire global civilization for a year equals what our sun produces in less than a billionth of a second. This perspective could be humbling to the point of despair, but it shouldn't be. Instead, it should fill us with awe at the incredible journey that lies ahead. We've learned that Type 1 civilizations don't just consume more energy, they transform their relationship with their planet, achieving harmony between technological power and ecological wisdom. We've discovered that Type 2 civilizations don't merely build bigger machines, they become gardeners of solar systems, nurturing life across multiple worlds while harnessing stellar power. Most remarkably, we've seen that Type 3 civilizations represent something approaching the divine, intelligences that guide galactic evolution itself, stewarding the birth of stars and the development of consciousness across billions of worlds. But perhaps the most important insight from our exploration isn't about these advanced civilizations, it's about us, right now. At this moment in cosmic history, we are living through what may be the most significant phase transition in the history of terrestrial intelligence. The decisions made by the next few generations of humans will determine whether Earth becomes the birthplace of a cosmic civilization or remains forever isolated in space. The great silence that haunts our galaxy suggests that this transition is perilous. Most civilizations may never reach Type 1 status. They may destroy themselves through war, environmental collapse, or simple inability to cooperate on planetary scales. Yet we have reasons for hope that earlier civilizations may not have possessed. We understand our impact on planetary systems. We're developing renewable energy technologies. We're beginning to think globally about challenges that affect our
entire species. Most importantly, we know about the Kardashev scale itself.
We can see the path ahead and the dangers that await us. Knowledge of the scale gives us something that earlier civilizations lacked, a roadmap for advancement that emphasizes wisdom alongside power. The energy revolution happening around us right now, from fusion research to space-based solar power, represents humanity's first serious steps toward Type 1 status. The space exploration renaissance, led by both government agencies and private companies, signals our species' growing readiness to become truly spacefaring. But technology alone won't be enough. The Kardashev scale teaches us that advancement requires not just more powerful energy sources, but more sophisticated approaches to cooperation, long-term planning, and environmental stewardship. The civilization that successfully navigates the transition to Type 1 status will be one that has learned to think beyond national boundaries while respecting cultural diversity. It will balance individual freedom with collective responsibility. It will pursue technological advancement while preserving the biological heritage that makes Earth unique. This transformation won't happen overnight. It may take centuries, but it begins with understanding that we're not separate from the cosmic story of intelligence. We are that story, unfolding right here, right now, through every choice we make. When you use renewable energy, you're contributing to humanity's transition toward Type 1 status. When you support international cooperation, you're helping build the institutional foundations necessary for planetary-scale coordination. When you advocate for long-term thinking about environmental challenges, you're developing the temporal perspective required for Kardashev advancement. The scale that Nikolai Kardashev created to search for alien civilizations has become a mirror showing us our own potential. What we see in that mirror isn't just the possibility of harnessing more energy, it's the possibility of becoming truly wise on cosmic scales. The stars aren't calling us to conquer them. They're inviting us to join the ancient conversation of consciousness that spans the galaxy. Whether we accept that invitation with wisdom or decline it through short-sightedness will determine not just our fate, but our contribution to the eternal story of intelligence in the universe. We stand at the threshold of cosmic significance. The path ahead requires courage, wisdom, and unprecedented cooperation. But the destination, taking our place among the advanced civilizations of the cosmos, represents the ultimate fulfillment of human potential. The Kardashev scale has shown us that we're not the end point of evolution on Earth. We're the beginning. The question isn't whether we'll reach the stars, it's whether we'll reach them as conquerors or as gardeners, as destroyers or as nurturers of consciousness throughout. The galaxy, the choice is ours. The time is now. The stars are waiting.